In order to install JMeter, we need to follow the steps. So first of all, we download Java, JRE, Java runtime environment. Then we install Java, download JMeter, unpack JMeter, and unarchive JMeter, and then run JMeter. So in order to download Java, we need to search for a keyword download JRE, Java runtime environment, and we have this link Java downloads for all operating systems. Following this link, you will see Java runtime environment for different operating systems, different OS like Windows, Mac, Linux, and Solaris. There is Windows Online for Windows for online, for offline, and for offline 64 bits. I will choose offline 64 bits. When you are clicking on this icon, the download should start. So you are choosing the folder, press save, and when the Java runtime environment is downloaded. After it is downloaded, you are just opening the corresponding folder and accessing it and install Java. Okay, after following the installation steps of Java, Java should be installed, and then you just we need to verify that the Java was installed successfully. We opening a CMD command line, and here we need to write Java version. Java version. So it is not installed. Let's install the terms under which. So install, we're pressing install. The Java is installed. After this, opening CMD and writing Java version. When writing Java version, it should say that the corresponding Java version 1.5 Java runtime environment, Java hotspot, and this means that Java was installed successfully, and we can now run Java applications. Since JMeter is a Java application, it was developed as a Java application. It requires Java to be installed first. So now, in order to download the JMeter, so we are on this step to download JMeter, unpack, and run JMeter. We need to access JMeter download, and there is a site Apache JMeter, jmeterapache.org, which is official site of JMeter. We need to access it and download the JMeter archive. So there are some different archives. I would recommend to use the source, binaries and source. We are using binaries since we are not developing a JMeter, but we are using JMeter. In order to use JMeter, we need only binaries. So we need to access zip archive and download the zip archive. Current version of JMeter is 5.6.3. We are downloading JMeter. We are copying JMeter to a convenient location, for example, D program files. We are copying archive here. Then we need to unzip. So a new folder is created, Apache JMeter 5.6, and here as well. So if you don't need this folder, you just delete it and copying a source on a single folder, Apache JMeter single folder 5.6. And there are different folders. In order to start JMeter, we need to access the bin folder. A bin folder, and in order to start JMeter on Windows, we need to access jmeter.bat. This file jmeter.bat, and we are just accessing it. A command line is starting JMeter. After starting JMeter from command line, a graphic user interface will appear. JMeter user interface. This is a user interface appearing. You will see how JMeter looks like. So okay. So this is a user interface. You can just adjust it. Different user menus, shortcuts for user menus, test plan, and the details, element details page. Now we will talk a little bit about JMeter folders. So when unarchived JMeter folder contains bin, docs, extra, sleep, licenses, printable docs. In the bin folder, you just access it in order to start JMeter, JMeter BAT or JMeter SH for Linux. And in the lib folder and the ext folder, you use this folder in order to install different plugins for JMeter. You download the corresponding plugin in the jar file format, and you just copy it in the lib ext folder. Then you need to restart JMeter in order to plugin to be available on the UI of the JMeter. What are JMeter plugins? JMeter plugins may be defined as software functionalities used in JMeter to extend features and insert functions. JMeter is one of the most popularly used tools for loading testing, and what makes it even more popular is the ability to extend its capabilities using plugins. So, in order to not hassle with downloading jars and installing jars manually into libext folder, and then to install it here, copy it here, and then restart JMeter every time when a plugin is installed, there is an automatic way to install plugins called Plugins Manager. In order to install Plugins Manager, we need to go to the following link, JMeter Plugins org wiki Plugins Manager. Then download the Plugins Manager jar and put the jar in the JMeter's libext directory. So we need to go to the following address, jmeterplugins.org wiki plugins manager. So we need to download the jar. Okay, we install this jar in D program files, Apache JMeter 5.6 libext. We install it here. So it is downloaded. So it is in libext folder. It is downloaded, JMeter Plugins Manager. So now we need to restart JMeter. Okay, we need to start JMeter again. JMeter. So let's minimize this window. if you close this window, the JMeter will be closed. So we only minimize window, and this window also the command line usually helps us with identifying errors. If a JMeter has some error, the error will appear here in the command line. Also, if we have an error when executing tests, the error will appear here, and when clicking on this exclamation mark, you will see the errors text trace in the JMeter console. Also, we downloaded Plugins Manager. Plugins Manager is located in Options, Plugins Manager. So here we have three tabs. Installed plugins, a list of installed plugins, all available, all the installed plugins, available plugins. This is the plugins which are available for installing, for downloading and installing, and upgrades. If there are any plugins which require upgrade, the corresponding plugin will be listed here. So let's see what are the top 5 JMeter plugins. So custom soap sampler, this is one. Perfmon, service performance monitoring. This is a plugin to monitoring resource usage like CPU, disks, network, memory on servers. Custom thread groups, stepping thread group, concurrency thread group, freeform arrays thread group, ultimate thread group, flexible file writer, and dummy sampler. Let's install a Perfmon plugin. So we are going to JMeter. We are going to install available plugins. We are going to available plugins. We search for Perfmon. So we have a Perfmon plugin. Now let's try to install it. Okay. So we are choosing, and we are pressing apply changes. We are choosing the plugin to install, and we are pressing apply changes and restart JMeter. After it's not obvious to how to install plugins. So in order to install some plugin from the list, you need just check the checkbox, and then press the apply changes button, which is located in the left side, left corner of the window. So the JMeter is restarting. It is restarted, and we now let's see if the plugin was installed. Yes, it was installed. It is listed in installed plugins tab. So performance server performance monitoring. So in order to use plugin, the plugin is listed in listener, and here we have show perfmon matrix collector, this one. So this is the plugin, and then in order to use it, you need I guess you need an agent installed on servers, or just list the server here, host and IP address and port and so on, and metric to collect. For example, like this one, CPU and so on. You're choosing CPU, for example, memory and so on. For example, CPU, memory, and disk. Okay, this is all about plugins. So plugins could be installed without manual installation. It could be installed in an automatic way by using JMeter Plugins Manager. You are just selecting plugins you want in the available plugins tab and press Apply Changes button, and that's it. So let's create. Let's see what is a thread group and what are the elements, the basic elements of JMeter. In order to, I will create a new test plan for this, and for a test plan to see how many active threads are running, we need a special plugin. So I will show what is plugin. The plugin name is Free Basic Graphs. It contains average response time graph, active threads, and successful failed transactions. So in order to create a test script, we need a thread group. A thread group, basically, this is a test script or a test scenario. A thread group should contain some steps, like a test case contains steps. A thread group also should contain steps. In order to organize our requests in steps, we need to add config element, a sampler. So there is a sampler, but there is a logic controller, simple controller, this one. Simple controller. In order to see what the element does, you are provided with help, with a documentation. In order to access documentation, you just need to click on an element, for example, simple controller, then right click on it and choose help. After this, browser page appears with a documentation for the corresponding element. The simple logic controller lets you organize your samples and other logic controllers. Unlike other logic controllers, this controller provides no functionality beyond that of a storage device. So it is only for organizing your test. So, for example, let's call this step one. Step one. For example, it will be login into application. Okay. Then we could have some more steps like this. Let's add 3. Then we will have, for example, step 2. For example, list go to products list, and then step 3, for example, step 3, go log out. Yes, for example, this one. And in this every step should contain some requests. We will add a sampler, HTTP sampler, HTTP request, and this request would call, for example, Google page, this one, HTTP request, and this request should be named somehow, and then we will add sampler HTTP request here and a request here. Every step could contain not only one request, but it could contain 2 or 3 requests or more requests. For example, second page will contain 2 requests, and second step will contain 2 requests, and the third step will contain, for example, 4 requests. Every request could have a name. A name is changed in the right section, in the details section. And this is how you are organizing your tests. So every test should be organized in steps. The steps is nothing else than simple controller which does not have any logic. A thread group controller is a controller in order to simulate a big number of users, for example 10 users or 100 users and so on. The ramp-up period in seconds means in how much time all the 100 users will be simulated, will be up, or will ramp up. So for example, in 10 seconds. And loop count is how many times, how many cycles, how many loops the corresponding scenario will have. For example, 1 or 10, 100 loops. Basically, when performing test, we are choosing more often we are choosing infinite option. So we are ticking infinite options. Also, there is an option, there is a setting here, action to be taken after sampler error. So, for example, when any of these requests are failing, for example, this one, what should be done with the corresponding thread? So it should continue. It should just continue on following requests, or it should start next loop, or it should stop thread, stop test, and stop test now. Very often the best practice says that we need to not to continue because there is an error page and the user cannot continue. Therefore, the best practice says that we need to start next thread loop on every error occurrence. Why this is needed? Because sometimes it is needed to correlate future request with the previous request. There is an ID or there is a token which is passed from step to step, and if one step is failed, the token will be invalid. So we need to not to continue, but we need to start the next thread loop. Okay, let's see how this works. In order to disable steps, disable elements, there is an option to disable them. And let's see, for example, that we are making a request. In order to see results, we need to add a listener called view results tree. Okay, so let's run this test with one user, ramp up period 1 second, and only one loop count. And in order to run, we need to save a test plan. For example, we are saving the test plan, and after this will run. So the corresponding request is successful. the green icon says that this is successful. There are three tabs here: sampler result, request, the request which is made. For example, here we can see the URL, get method, cookies, and so on, and the response data. Response data is a response body. In response body there are HTML document. Response headers are visible as well. So in order to fail this request, we need to add assertion. For example, for this request, we are adding an assertion which is, for example, a response assertion. Response assertion, we are asserting that, for example, a response code should equal to 200, a successful request. Let's run this. Yes, it is passed. And if we are setting that we are expecting the response to be code to be 201, we will have a failed test because as a response code was 200, was successful, but we are expecting it to be 201. So we received 200, and comparison value is 201. So this one, 201. So it is the assertion is comparing the response code, and if it's not equal, then it fails the request, and the request is marked with corresponding icon, red icon. So in each step we have a thread group. In each test we need to have in the test script a thread group which simulates the number of users and number of concurrent users. We have a simple controller. We are grouping elements in order to group requests in steps. We have a sampler, HTTP request. We could change the name, and in each request we could have assertions. Assertions are nothing else than a verification. Which verifies, for example, a response code, a text response, response message, response headers, and so on. And the matching rules are contains, matches, equals, substring, not, or, and so on. And here we could add much more lines, much more things to test in a single assertion. Let's talk a little bit about a thread group. So a thread group is simulating a number of users. Let's delete a session for now. And for example, we'll simulate 100 users, 10 users, for example. Let's clean results. We are setting 10 in number of threads, number of users or number of threads, 10, ramp period 1, loop count 1. And when starting the test, we will see that only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 requests are made. So in order to make more requests, we could add, for example, we could add more users, or we could add more loops. For example, if each thread will execute in 10 loops, then 10 multiplied by 10 will be 100. Let's see if this is correct. We are starting the test, and we could see that there are 100 requests. In a normal way, in a usual way, we are selecting here a loop count to be infinite. Then if we will start the test, there will be a huge amount of requests. So here we are saving an error because Google just blocks us in order to not blocks the same IP address. So also we could choose a ramp up period. For example, we could choose 10 users. For example, 100 users will be ramped up, will be up in 10 seconds or 30 seconds or a minute, and so on. So in order to see how many threads are active at the current moment, we could add a special listener called active threads over time. So we are setting 10 users, ramp up period 1 second, and loop count 1. When starting the test, we are seeing that there are 4, then 3 users, so number of active threads. And for example, let's loop count to be infinite. When starting the test, you see that 10 users are continuously working, 10 active users, 10 concurrent users are continuously working on the same page or the same request. For example, let's set these 10 users to be ramp up period to be 10 seconds. When starting the test, you see that in 10 seconds, all 10 users are up. So from here to here, there are 10 seconds, and very continuously working on the same request. This is because I chose loop count to be infinite. We are clearing Control E to clear, so clear all results. Control E. We could select this one. Saving the project. We could specify thread lifetime, so duration. This is a duration of thread lifetime, and startup delay options. For example, if a test lasts for an hour, then this would be 1800, and so on. So I just wanted to show you, for example, let's create a new project. In order to see what, let's see what options JMeter have, and what elements, and what is the structure of a project should look like, and so on. For JMeter have so standard options operating with projects and files, a standard menu, a file menu, edit menu, where you can edit an element, you can search an element, base name, and so on. There is a search functionality. A run script menu, in order to start, to stop, clear results for an element, or clear all results, and so on. There are options, different options, tools, help, and so on. So a very important feature in JMeter is accessing help documentation for an element. If you need some kind of documentation for an element, how it is used, and what are best practices, what elements, and what options could be used for, and what are the values for for the options for the corresponding element. You're just accessing right click and help, and you're accessing the elements documentation on the web. So these are documentation, and you're accessing not only all documentation but only a specific documentation for a specific element, and you are provided with all the information, description, parameters, and so on. So let's see. In order to start at a script, you need to add a thread group. Then you just notice that when adding at the thread group level, we have only a thread group, setup teardown thread group. We have a config element, which is CSV dataset config. This config is used when you need to attest data for a scenario or for all the scenarios in the CSV format, comma separated value formats. So first of all, you are creating the corresponding file. When you are adding the CSV dataset config, you are specifying the file path, and you are using the corresponding file as test data for your scenario. HTTP header manager, HTTP cookie manager. This is a manager for the cookies. In order to see HTTP cache manager, the manager for the cache of your scenarios, and HTTP request defaults. HTTP request defaults usually, so this kind of element should be located at the top of test script of your test plan, and in a test plan you could have much more this kind of elements, like for example cookie manager. Then for example, let's add some more cache manager and the CSV config. And these elements basically are should be located at the top of your test plan. When you have a thread group, this is a scenario. You could have much more, multiple such scripts, such scenarios, and or you could have one, for example, or much many, and so on. For example, let's analyze HTTP request defaults. So these are defaults for all the requests we are located in the test plan, which are located in the test plan, defaults to be used. If we will write here an HTTPS option value, then this value will be used for all the requests. And for example, if we will specify a Google.com server, then this server name will be a root, a path for root path for all the requests. And at the test plan level, I said that there are different elements allocated the root elements, like thread groups, config elements, and listeners, timers, preprocessor, postprocessor, and so on. At the thread group level, there are much more options, like sampler, and we have an HTTP request, a basic request which could be a get, a post request, a put request, and delete, and so on. Then we have this type of requests are used for testing web applications, and we have for example a JDBC request. A JDBC request is a request usually used for testing databases, and so we have TCP request. This request is used for testing applications which are communicating through a TCP protocol. LDAP request, this is for LDAP database, a JMS publisher, and just JMS subscriber. This is basically for testing QEs, and FTP request, which is used for testing FTP servers, and there are many more, so you could use but usually we are using HTTP and JDBC request. Okay, at the thread group level we have sampler, different types of requests, different types of samplers, and we have a logic controller. Logic controller, you add a logic controller when you want, for example, your request to be executed depending on some logic. For example, there is an if controller, transaction controller, loop controller, while controller, for each include interleave, random controller, simple controller, and so on. Simple controller has no logic. This is for grouping requests together in steps. So for example, if controller, let's say an if controller. So let's access its documentation. The if controller allows user to control whether the test elements below its children are run or not. So, depending on the logic, the corresponding the children which are located in if controller will be executed or not. So, expression must evaluate to true or false. So you write a variable or an expression, for example, some variable 1, and this variable, for example, which will be set before if controller, and if the corresponding variable will be evaluated to true or false, the corresponding elements will be executed. There are also some controllers like loop controller, so you could loop through the samples located in the as child samplers, could loop an infinite amount of time, or depending on some loop you specify, and so on. There is while controller, transaction controller, random controller, and so on. Also, there are such elements like preprocessors. Preprocessors, for example, bin shell preprocessor, which is some kind of logic, some kind of code which is executed before the request, is executed, and postprocessor. This is some kind of logic which, for example, if we are talking about bin shell, bin shell lets you execute some code, some script, and this bin shell is called a processor, and since it's called a processor, it means that the corresponding script, corresponding code will be executed after request is executed. Some basic famous postprocessors are JSON extractor, which is an element to extract some value, some kind of value, and store it in variables extracted from by using a JSON. And regular expression extractor, which is very often used by engineers, which is extracting a value located in the response. It could be located in the response, or it could be located in the HTML body of the response, and it extracts some value based on regular expression. Let's access its documentation, and we'll see what the documentation says about regular expression. So regular expression extractor allows the user to extract values from a server response using a parallel type regular expression. As a post-processor, this element will execute after each sample request in its scope, applying the regular expression, extracting the requested values, generate the template string, and store the result into the given variable name. So this is how it looks like. You give a variable name, you give a regular expression to extract a template, a match number, and default value. You basically specify not found default value, and it extracts a value from body. You have an XPath extractor as a post processor, so extracting values based on XPath. Also, for this is what it is related to post processors, and also we have listeners. So view results tree listener, which is which allows us to view the results based on each request which is made. Also, we have aggregate report listener, which is very often used. This is the basic element for generating reports, and it contains response times. It contains error percentage, number of samples which are made, and so on. So let's delete additional unnecessary elements, and let's execute. Let's execute this request. For example, 10 times, and let's see how it is, how aggregate report is looks like. So let's execute. A number of samples. Then we have a minimum, response time minimum, and we have an average, and we have a maximum. Then we have an error percent. Where percent is then we have throughput, 90% line, 95% line, and so on. So basically these are used. Number of samples are used: minimum, average, maximum, and error percent. Let's analyze why it is error. Let's add view results tree. Let's execute this test. It looks like, okay, this is not our okay, that's all related to thread group menu. So samplers, logic controllers, preprocessor, post-processor, assertions, timers, and so on. But we could have different kind of listeners as well. So there are different plugins which are listeners are used often for reporting. So there are plenty plugins which are letting us add different type of listeners, including PerfMon listener, which is monitoring performance counters. Of course, we have timers, different kind of timers like constant timer, uniform random timer. We have assertions, which are verifications. For example, they are verifying that the response is fine. For example, a response assertion and different kind of size assertion, HTML assertion, which verifies responses, HTML, and so on, XPath assertion, and so on. In this lesson, we will talk about how to record the requests, how to record the script based on user actions on the browser. So in order to record the script from the browser, we will need to add a special non-test fragment HTTPS test script recorder. This recorder, we are specifying the port we will use for recording purpose, and we will specify to filter all the requests which are dealing with resources such as images, CSS, and so on. So we are adding this excludes by pressing add suggested excludes button. After adding the test script recorder, in order to recorder to work, we need to access in Firefox browser. So we need to access settings, and we need to search settings for proxy. So we need to set a proxy. In the proxy, we need to set following configuration: manual proxy configuration. Just tick it and specify localhost and the port 800, the same port as specified in JMeter. Press OK. Then after pressing start, so it says that target controller is user recorded, but no such controller exists. So we need to specify target controller could be two types. It could be recording controller. Recording controller is a special element. In threads, is a special element. It is located somewhere here. Listener. Where we can, the second way in order to record the script is to use, for example, test script recorder. When pressing start, it generates Apache JMeter generates a certificate, and this certificate should be installed in the browser. We are stopping for now, and we are going to bin folder of JMeter. And there is a Apache certificate which is generated. So we need to import it in Chrome by searching for certificates, view certificates, and import a certificate from the bin JMeter's bin folder. After importing, pressing OK, you'll see, just check the list of certificates. You will see the JMeter certificate in the list. When importing this certificate into the browser, you will see two checkboxes: trust authorities and trust another one checkbox also related to trusting. So we need to check both checkboxes, pressing OK, and certificate will be imported just fine. In order to see how it works, let's start recording. And now we are accessing on Apache JMeter site. Let's access some links, for example, Java docs. After accessing this link, the request is recorded here in the script recorder. So if you click on the request, you will see that there is a server name JMeter Apache work, and the type is a GET request, and the URL path. Let's access, for example, some link, and you will see that after accessing this link, a second request is recorded. So this request, if you expand this request, you will see the headers, all the headers which are recorded, and you can just let's stop the recording. And when developing scripts, you're just creating a script, for example, a thread group. You're creating a step, for example, sampler, simple logic controller, simple controller. This is for example, step one, and in this step you're just not you could create a sampler, but instead of creating, you're just copying the requests from script recorder, the recorded requests, just copying them here, and you are provided with a full request and all the headers required in order to perform this GET request. In such a way, you are recording all the requests, and the test script design stage is much more convenient for you, and it takes much less time in order to develop scripts. So we will talk about samplers. In JMeter, samplers are crucial components that simulate requests to a server, service, or API, essentially mimicking the behavior of a user interacting with a web application. They are elements that actually perform the actions in your test plan, such as making HTTP requests, sending database queries, or interacting with a web service. Samplers tell JMeter what type of request, like HTTP, FTP, JDBC, to send and how to send it. This is the list of samplers. We have HTTP request sampler, FTP request sampler, JDBC request sampler, SOAP request sampler, bin shell sampler, JMS publisher subscriber sampler, mail reader sampler, debug sampler, JDBC pre and post processor sampler, and LDAP request sampler. HTTP request sampler. The purpose is to send the HTTP request to a web server. Most commonly used sampler essential for testing web applications. You can configure the request method get, post, put, delete, etc. Specify the URL, headers, and parameters and body data. It supports cookies, authentication, file uploads, and redirects. So in order to add this kind of a HTTP sample, you need to add a thread group. Then you need to add a step, test case step. For example, it will be logic controller, simple controller. For example, let's name it step 1, login. And we are adding a sampler, HTTP request sampler. So it has a basic and advanced tabs. You can specify get, HTTP method like get, post, head, put, options, trace, delete, patch, and so on. You are specifying the path, the server name, for example, blaze.com, and you're specifying the path. And here you can add some more parameters, or if it is a get, if it is a post, you can add parameters or body data like JSON. So the next sampler is FTP request sampler. It simulates FTP protocol requests to test file upload, download scenarios. It is useful for testing FTP servers. You can specify the server, port, remote file path, and actions like upload or download. Allows configuring login credentials and transfer modes. So let's disable this one. We are adding and now the type of sampler like FTP request, and it has a server name, remote file, local file gets so get put, and it has username and password. If you need more detailed information about this sample, you can just right click on it and select help, and it will retrieve documentation from the web. So this is all the necessary document. You can see the details and so on. Okay, the next sampler is JDBC request sampler. The JDBC, this sampler sends SQL queries to a database. Useful for testing database performance. You need to configure JDBC connection, provide SQL queries, and choose the query type. Select, update, insert. Supports parameters, variable substitution, and dynamic query execution. So we are disabling this sampler. We are adding sampler like JDBC request, and here you can write the query and select the query type like update, prepared, callable, prepared, select, prepared, update, commit, rollback, auto commit, and specify the parameters, variables, and so on. A next type of sampler is a SOAP request sampler. It sends SOAP or XML RPC requests to web services. Ideal for testing web services that use the SOAP protocol. You can specify the SOAP message, endpoint, and other parameters. It supports VSDL-based services, can send raw XML payloads. So where is SOAP? So we have a bin shell debug for control. Okay, I will see how to edit in project later. I will show you. We have the next sampler is a bin shell sampler. It runs bin shell scripts to execute custom code, provides flexibility for complex test scenarios where standard samplers are insufficient. You can write Java code to handle unique situations or perform custom logic. Full access to JMeter's API, enabling dynamic request construction or custom reporting. So here you can bin shell sampler. So here you can specify your script, and the corresponding script will be executed. You can specify script file or the script and parameters. JMS Publisher Subscriber Sampler. This sampler is for testing simulates JMS, Java Message Service, message sending or receiving. This is for testing queues. It is suitable for testing messaging systems like ActiveMQ or RabbitMQ. The publisher sends messages to a JMS queue or topic, while the subscriber reads messages. The features are that it supports different messaging modes, durable subscriptions, and transactions. So there is a JMS publisher. This is how it looks. So you can specify authorization, you can specify properties, you can specify the text message or object message serialized to XML by Xstream, and you can specify the message type like text, map, object, bytes, message source, text area from file, and so on. And we have this is a publisher, and we have a subscriber. JMS subscriber. So this is how it looks like. It reads messages. So the next type of samplers is mail reader sampler. It connects to an email server, for example, POP3, IMAP, or SMTP, and reads emails. This is ideal for testing the performance of email servers or checking email content, useful for checking the results of actions like user registration or password reset where confirmation is sent via email. It supports authentication, SSL, TLS connections, and various email protocols. Let's disable this one, and we will add the mail reader sampler. This is how it looks like. You can specify the protocol, the server host, server port, username, password, folder, and you can specify the number of messages to retrieve. So you can use SSL, TLS, or no security features. You can specify that to delete messages from the server, and so on. The next type of sampler is debug sampler. The purpose is to debug the JMeter script by displaying variable and property values, not for load testing but helpful during script development. Outputs all JMeter variables and properties to the log or listeners. Provides detailed insights into the state of the script during execution. So let's see. This is a debug sampler, this one, and you can specify whether to display JMeter properties, JMeter variables, system properties, and so on. Okay, the next sampler is JDBC pre and post processor sampler. The purpose is to execute the SQL commands to prepare test data or clean up after a test, help set up or tear down data for database related performance testing, can be used to ensure a consistent state of the test environment. So let's add JDBC preprocessor. In preprocessors, you can find JDBC preprocessor and JDBC postprocessor. In postprocessors, there are JDBC postprocessors. So you are specifying the query in order to run before a JDBC request and after the JDBC request, and this makes your test executable any number of cycles. Okay, and we have LDAP request sampler. This sampler is tests LDAP directory servers by simulating operations like search, add, modify, and delete, used in environments where applications interact with directory services for user authentication or authorization. Supports various LDAP operations, authentication, and connection pooling. Okay, let's add some LDAP request. You can specify login information, username and password, server name, port, directory name, DN. And you can specify test configuration, user-defined some tests, the add test, delete test, search test, and modify test. Regular expressions, often abbreviated as regex or regexp, are patterns used to match character combinations in strings. They are a powerful tool in programming or searching, editing, and manipulating text based on specific patterns. Regular expressions are widely supported across different programming languages, text editors, and tools like grep, sed, and awk. Key concepts are regular expressions. Regular expression consists of a sequence of characters that define a search pattern. This pattern is then applied to a string to find matches, extract data, or perform search and replace operations. Here are some key components. Literals, plain text characters that match exactly as they are. For example, the regex cat matches any occurrence of a word cat in a string. Meta characters, like characters that match dot matches any single character except new line, matches the start of a string, then $sign matches the end of a string. These are the special characters with specific meanings in regex syntax used to define more complex patterns. Some common meta characters include matches zero or more occurrences of a preceding character group. Plus sign matches one or more occurrences of a preceding character group. Exclamation mark, question mark matches zero or one occurrence of a preceding character group, and so on. There are character classes, quantifiers. For example, there is a quantifier. Quantifiers define the number of times a character group or character class should appear. There is a sign that matches zero or more times, plus sign matches one or more times, then there is a symbol that matches zero or one time, and so on. There are anchors and groups and back references. And you can see some examples of regular expressions and um, which are used to match some specific words. Practical uses of regular expressions are search and replace. Regular expressions are commonly used to search for patterns in text and replace them with different strings. For example, finding all phone numbers in a document and formatting them uniformly. Input validation used to validate user inputs in forms, for example, checking if an email, phone, or password meets certain criteria. Text parsing, extracting specific pieces of data from text like dates, times, URLs, or specific words. Log analysis, used by system administrators and developers to search and filter logs for specific entries, error messages, or patterns that indicate issues. Data cleaning, cleaning up messy data by removing unwanted characters, white space, or formatting issues. Syntax highlighting, and so on. So there are regular expression tools and libraries, Python, JavaScript, Java, and so there is regular expression patterns and cheat sheet you can use. As a conclusion, regular expressions are a versatile and powerful tool for text processing and manipulation. They are essential for tasks ranging from simple searches to complex text parsing, input validation, data cleaning, and much more. Understanding regex syntax and patterns allows you to leverage them effectively in various programming and data processing contexts. So there is a regular expression in JMeter. Regular expressions in JMeter are commonly used for parsing and extracting data from server responses, such as headers, body content, or specific strings. This is especially useful for dynamically handling data in performance testing, like capturing session IDs, tokens, or any other parameters that change per user or request. How regular expressions work in JMeter? In JMeter, regular expression extractor is a post processor that applies regex patterns to the response data. When the pattern matches, it extracts the data and stores it into variables for use in subsequent requests. The extracted value can be used to parameterize requests or assert the correctness of responses. How to add the regular expression extractor in JMeter? You just right-click on the sampler, like HTTP request, where you want to add the extractor. Go to Add Post-Processor's regular expression extractor. Fill in the necessary fields, for example, reference name, the name of a variable to store in the extracted value, regular expression, the regex pattern to extract data, template, defines which part of a matched regex group to return, match number, which occurrence of a match to return, 1 for the first match, -1 for the random, and 0 for all matches, and default value, the value to return if no match is found. So regular expression examples in JMeter. So there is, for example, this example shows how to retrieve a session ID value. So you need to write session ID equals, and then follows the regular expression. So this stands for characters, for small characters, then big characters, and numbers from 0 to 9 occurred one or more times. So it will extract the value of a session ID. Explanation: the pattern session ID matches the literal session ID, and then this one, the value regular expression and the brackets is a capturing group that matches one or more alphanumeric characters. The extracted value ABC123XYZ can be stored in a variable like session ID and used in subsequent requests. You can see some more examples here. I will attach this file as a downloadable resource. So this is how to use regular expression. You need to fill in all the necessary fields in JMeter. So I will show you how it looks like. For example, let's go to JMeter and we will start JMeter. This is an example how to populate the fields in regular expression extractor element in JMeter. So the JMeter screen appears. Let's add some thread group. Let's add some request element, and you will need, in order to set a regular expression extractor for a request, you need to right click on the request and add post processor, and you need to add regular expression extractor. This regular expression extractor will extract some value from the response, which is coming from the server, because this is a post processor, so it works after the request is made, and it works with a response. And you need, for example, you need to fill in name of a variable, regular expression, template, match number, and default value. So you need to apply it on main sample. You fill to check body or body unescaped, or you can check response message. response headers, and so on. So this is an example how to populate. For example, variable name will be session ID. So we are writing here session ID. When we need to fill regular expression, for example, it will be like that session ID equals, and then the capturing group, then a template. This is a standard value for a template, $1. Then you need to fill match number 1 and default value no match. Default value no match. And the extracted value will be stored in session ID variable, and this variable should be used in further requests to the server. In order to, so let's tips for writing regular expressions in JMeter. So you need to test your regex independently. So use tools like regex 101, regexer, or built-in JMeter view results tree listener to test your expressions. Use groups wisely. Always capture what you need using parentheses and avoid unnecessary groups. So this one should be used in order to capture values. Keep expressions simple. Simplify expressions by focus on unique patterns to match. Avoid overly complex patterns that can impact performance. Use non-capturing groups when needed. Use this one for groups you don't need to capture. It reduces memory usage. Handle edge cases. Consider cases where the expected text may be missing or formatted differently. Provide a sensible default value to handle such cases gracefully. In conclusion, we can say that regular expressions in JMeter are crucial for extracting dynamic data from server responses, enabling you to create more realistic and dynamic performance tests. By mastering regex, you can handle complex scenarios like session management, token extraction, and dynamic parameterization, ensuring your tests accurately reflect real-world usage. So in order to test your regular expression, you can use JMeter. So there are elements to show what values are stored in the session ID, but you can use also online tools like this one. You just type regular expression online test. And there are some choices like regex 101, regex, and so on. Let's access this one, and here you just need to insert a string, test string, and then you need to insert a regular expression. And let's see, for example, this example. So there is a link which stores a session ID, this string. So we need to extract the session ID value, this value, ABC. Then we need to write a regular expression. In order to write a regular expression, we use this one, session ID, and the regular expression. This is a capturing group, range, and quantifies one and unlimited times. And it shows us that this is the matched value. And you can test your regular expression. For example, if we write here session ID 2, it will not find anything. And if we write session ID 2 in the test string, and it finds again the correct value. So let's talk about a real example. This is a real JMeter project. I have added in test plan. I have added a thread group with one single user for debug purpose. Have added a simple controller. This is a step 1, for example, login step. And I have added a simple request which is pointing to blazedemo.com. This is a testing website. And I have added a debug sampler debug sampler is added by adding sampler and then choosing debug sampler, and it has following options like JMeter properties, JMeter variables, and system properties. What it does, it just displays all the JMeter variables in a view results tree in a separate sample. So in the view results tree, if we need to add in order to see the variables, all the JMeter variables in the project, we need to add a debug sampler. Then we need to add a view results tree, and after executing the test, we see the request, which is added in the step 1, and we see a separate sample for debugging purpose. And if you go to response data and response body, you see all the variables which are handled by JMeter. And we have also a variable name session ID. This variable comes from regular expression extractor. You are adding it by accessing post processor and the regular expression extractor. In this, I have set a variable name to be session ID. I have set a session a regular expression I have set a template, standard template, and match number is 1. And if it does not find any session, the value should be no match. So if we see on in the response, if we search for session, there is no such element. And if it is not found, the value should be no match. And if we read the debug sampler, there is a session ID with a value no match, and this is correct. And in order this extractor to work, we need to have in response body, we need to have some the session ID, or for example cserf token or some kind of token we need to extract. And this extraction is useful when we are dealing with correlation. For example, this session ID would be used in the next in the further requests. I am saving the project, and I will add the project as a downloadable resource, so you can have the project, this project as well, and test the same project on different websites, for example, blazedemo.com or any kind of other test websites. So we have XPath expression. XPath, XML path language, is a query language used for navigating through and selecting nodes in an XML, extensible markup language, or HTML document. It provides a way to traverse the structure of an XML document and retrieve specific elements, attributes, text, or other content. XPath expressions are essential in various applications, including web scraping, test automation, and data extraction. So we have such concepts of nodes and node types. The node is primary unit in an XML or HTML document. XPath operates on these nodes. For example, a div element node, span element node. We have attributes. For example, an attribute of ID with some value of content, text nodes, comment nodes, root nodes, and so on. XPath expressions. An XPath expression specifies a path to navigate through the document's hierarchical structure. It can be absolute or relative. We have an absolute path and we have a relative path, double slashes. For example, this XPath double slashes and div selects all div elements in the document. And we have the syntax of XPath and there are some examples of XPath expressions, like selecting all elements with a specific tag, and double slashes and div selects all div elements, select element by attribute, for example, input with some attribute which has a specific value username, selects an input element with name username. selects all elements containing a specific text. For example, P contains text example, selects all P elements containing the word example. We have axis, XPath use cases, for example, web scraping, test automation, data transformation, and configuration and parsing. Web scraping is about extracting specific data from web pages, product names, prices, and reviews. Test automation is about identifying web elements for automation tools like Selenium. Data transformation, transform XML documents using technologies like XSLT. Configuration parsing, extract values from configuration files stored in XML format. Tools for XPath testing. We have browser developer tools, online XPath evaluators, XPath plugins for EDEs, and so on. So we have advantages of XPath. Flexible and powerful, standardized, and supports complex queries. We have limitations of XPath performance. For example, complex XPath expression can be slower than CSS selectors in some contexts, such as web automation. Readability, long or complex XPath expressions can be difficult to read and maintain. Browser compatibility, some XPath functions may not be fully supported in all browsers, particularly older ones. XPath vs CSS selectors. XPath supports more complex queries, including selecting by position or text content. You can navigate both up and down. The document tree, select parent nodes. Syntax can be more verbose and complex. CSS selectors, generally faster and more readable for basic use cases, cannot select nodes based on text content or navigate upwards in the DOM. Commonly used for styling and simpler scripting tasks. And also we have information about XPath extractor in JMeter. In Apache JMeter, the XPath2 extractor, also known as XPath regular extractor in older versions, is a powerful post-processor element used to extract content from the XML or HTML responses of HTTP requests using XPath expressions. It enables you to define an XPath query to select and extract specific data from the response, which can then be used in subsequent requests or sessions within your JMeter test plan. A key feature is a XPath expression, multiple matches, namespace support, syntax, and extract from HTML. In order to use it, you need to add it to a sampler. I will show you how to edit. So we have a test project here. You just need to access post processors, XPath extractor or XPath2 extractor. In XPath extractor, you're just adding the name of a variable, XPath query, match number, and default value if the corresponding element is not found. You need the debug sampler, and you can see all the variables in a debug sampler response. So we will talk about templates. JMeter templates are pre-configured test plans that provide a quick starting point for common testing scenarios. These templates help users to save time by offering ready-made configurations for different types of testing, such as web application testing, database testing, and API testing. JMeter comes with several built-in templates that cover a wide range of use cases. Here are some of the most popular JMeter templates. Recording template. The recording template is designed to help you capture or record HTTP, HTTPS traffic from a web browser or application. It sets up a proxy server in JMeter, allowing you to record all requests and responses while interacting with a web application. Use case useful for creating test paths based on real user interactions with a website or web application, ideal for simulating user behavior or creating performance tests that closely mimic actual usage patterns. Building a web test plan template. This is a web test plan template is a basic template for building a web test plan from scratch. This template provides a simple HTTP request, sampler, and common configuration elements. Database test plan template. Template for testing databases using JDBC. It includes configuration elements for connecting to a database and performing a SQL queries. A SOAP web service test plan template. This template is designed for testing SOAP-based web services. It provides the necessary configuration to send SOAP requests and analyze the responses. A JMS point-to-point template. This template is used for testing Java Message Service, JMS. So in order to test queues, JMS queues, point-to-point messaging such as sending and receiving messages through a queue. JMS Publisher Subscriber template. This template is for testing JMS Publisher Subscriber messaging models. It helps in testing how messages are broadcasted to multiple subscribers. Building a monitor test plan template. A template for creating a test plan to monitor the performance of a web server, such as CPU usage, memory usage, or other server statistics. WebSocket test plan template, a template for testing WebSocket-based applications. It provides the configuration needed to open a WebSocket connection and send messages and handle responses. FTP test plan template, a template for testing FTP servers. It provides the necessary configuration for connecting to an FTP server, uploading, downloading, or deleting files. And Ultimate Thread Group template provides a more advanced thread group setup compared to the standard thread group, allows defining complex load patterns with multiple stages, ramp up, plateau, ramp down. How to use JMeter templates. So you need to open JMeter, select a template, go to File Templates, or click the Templates icon toolbar, and a dialog will open with a list of available templates. You choose a desired template, select template you want to use, click Create to generate a test plan based on the selected template. You are customizing the test plan and then run the tests. Advantages of using JMeter templates. It saves time, provides a quick starting point with pre-configured elements, reducing setup time, reduces errors, uses standardized setups, minimizing the risk of configuration errors. Best practices is templates follow JMeter best practices, ensuring an optimized test setup. Ease of use, ideal for beginners who need a structured approach to creating test plans. JMeter templates are an excellent way to quickly set up test plans for a variety of use cases, from simple web tests to complex database, WebSocket, or JMS testing scenarios. By using these templates, testers can save time, avoid common pitfalls, and ensure that their test plans adhere to best practices. So we'll open JMeter. You can find, and usually when we start working, we are just adding a thread group, for example, one thread group, second, and so on. And we are adding a recording controller, for example. This will be a recording controller. We are setting up controller when we need to add some steps and some simple controllers. For example, simple controller. For example, step 1, login. Step 2, access products page, and so on. And we are adding, for example, step 3, and so on. When we basically add all the recorded requests from test script recorded to corresponding step. So just one request, second request, and so on. When we are adding manually the config elements. For example, we need a cookie manager, and cookie manager goes here. We need, for example, we need request defaults. Also, we need a CSV dataset. For example, if it is about test data-driven testing, we need some test data in a CSV format. When we use the corresponding test data in our script. For example, if we deal with authorization we need an authorization manager, and so on. So authorization, for example, like cache manager, and so on. And these elements are all added manually. In order to avoid this, we are accessing templates. So we accessing file templates, and then we have a list of a basic list of most popular templates. And for example, we will choose a recording template. We are pressing create. We are configuring the template, customizing it. We are pressing create, and all these elements are added automatically. We just need to customize it, to change some properties, and that's it. So the templates are very useful. Let's talk about running JMeter in non-GUI mode, in non-graphical user interface mode. So running JMeter in non-GUI mode is recommended for several reasons. Performance. The GUI mode can be resource intensive, consuming significant CPU and memory. In non-GUI mode, JMeter runs more efficiently, especially for large test plans, because it doesn't need to render the graphical interface. Scalability. Non-GUI mode is better suited for running large-scale load tests because it handles a great number of threads and users more effectively without the overhead of a graphical interface. Stability. Running tests in non-GUI mode tends to be more stable and less prone to crashes, as the GUI can sometimes become a bottleneck or a source of errors, especially with complex test plans. Remote execution. Non-GUI mode is essential for running JMeter tests on remote servers or in distributed testing environments. It allows you to execute tests on a server where a graphical interface may not be available. Automation. Non-GUI mode is better suited for integrating JMeter tests into automated build and continuous integration pipelines. It enables you to run tests programmatically and collect results without manual intervention. To run JMeter in non-GUI mode, we need to use the following command line. Typically, this is a following command line: JMeter -n-t testplan.jmx -l results.gtl. N specifies non-GUI mode. T specifies the path to your test plan file, and -l specifies a path to the results file. So let's open a JMeter. Let's create a simple test plan. For example, let's adding a thread group. Let's add some, for example, HTTP request, and I will add the request to Blaze demo. Blaze demo. So this is blazedemo.com, protocol HTTP. We will add, for example, logic controller, a timer, a constant timer, 1 second delay. We will run the thread group for example, 10 loops, 10 cycles, 1 thread, and ramp a period 1 second. Okay, and we need to add listener like view results tree and aggregate report. Okay. Now in the view results tree, okay, let's test. Let's run a smoke test. We need to save a test plan. non-GUI mode, and let's okay, let's save the for running in non-GUI mode. We need to save only errors, so we need to check the errors checkbox on the view results tree, and we need to save this to a file. For example, save the result into a file. For example, we will create a folder like non-GUI mode. This is for the test plan, and we'll save for example, view results tree results tree.csv. Okay, this file will be created, and in this file only errors will be logged. In the aggregate report we also need to create a file, so we'll aggregate report.csv. Okay, and we are saving it, and let's start the test. We have a number of samples, minimum, average, and maximum, and the percent of errors. The percent of errors is 0. It's okay. So when the file was created, so we have I will show you the files. So we have a test plans, non-GUI mode, and these are the files: aggregate report and results tree. Results tree file should log only errors. So if you open the corresponding file, it is empty, since there are no errors. Everything was successful. And we have an aggregate report file, and we have some data about requests in the aggregate in the corresponding file. And if we clean, for example, in order to read from a file, we need to clean interface, and for example, run clear all, Control E, and then we need to press enter in the file name field. On pressing enter, it reads all the data from the file. When running again, for example, we clearing everything, and when running again, we have presented to the options: append to the existing file, don't start, or overwrite the existing file. So we choose overwrite. Or you can choose for the better option would be to go to the corresponding location and delete the files before every test execution. Okay, so we are saving the test project, and now we need to go to JMeter bin folder. We are opening PowerShell window in the corresponding folder. Then we need to copy the command line. So the test plan would be performance testing, test plans. So would be this one. non-go-mode.jmx, and the results file would be non-go-mode. Okay, and this command should be copied to. So here we need to have this one. This command should be copied in the PowerShell window. So now we have an empty folder with the reports. We have a project saved. Let's save once again the project, and by hitting enter, it should run the test. Okay, the test is run. When running the test, we are presented with a report, intermediate report, for example, the error percentage, minimum, maximum, average in seconds, or the response is average in seconds, and so on. So the test is run. When going to the, for example, in non-GUI mode folder, we have 3 files created. So this is for aggregate report, results tree, CSV, and results GTL file. Let's open GTL file and see how it looks like. So this is the information about all the requests. Okay, in order to read the corresponding reports, we are going into a graphical user interface and just hitting enter, and all the information is read, and we can see the error percentage, minimum, average, maximum, and so on. Also the same for results tree. If it is empty, then no results occurred. So this is how to run the test in non-GUI mode. In the future lessons, I will show you how to stop JMeter execution in non-GUI mode gracefully, and in order not to force it, but gracefully. So in order to stop the test, for example, you need to press Control and C. Control C. For example, let's start the test. Let's clear the log files, and then let's start the test. So the test is running. Let's wait for intermediate result to appear on the screen. Okay, let's press Ctrl C. Okay, let's try once again. So pressing Ctrl C, there's a display message terminate batch job, yes or no. So pressing yes, enter, and the tests are shut it down. So let's talk a little bit about how many instances of JMeter we need to use during a load test. Usually we use two instances of JMeter. So during a load test we use two JMeter instances. The total number of users will be 50 concurrent users. Ramp up period of time will be 3 minutes, and the load test duration will be 2 hours. 3 minutes, this is a period of time all 50 users will be up. So two instances of JMeter will be used during a load test. First instance is a load generator instance and will run 49 users, and second instance will be a collector instance and will run a single user. Collector is collecting response times and errors. This is done in order to collect response times when all concurrent users are loaded, ignoring ramp-up period of time. So this is, I have a chart. For example, we have a number, two axes, number of users and time. On time axis, we have a ramp-up period of time. So this one is ramp-up period of time, and for example, it will be 3 minutes. For more number of concurrent users, this ramp-up period of time should be increased in order to not to stress the system. And the load test will last for 2 hours. A load generator will be up, including ramp-up period of time and the total load test period of time. And this is 3 minutes plus 2 hours. All this period of time, the load generator will be up. And the first instance will be collector, and it will be up only when all 50 concurrent users will be up. So starting from 3 minutes till 2 hours and 3 minutes. So let's see how we configure this test. So this is the first JMeter instance, load generator. In load generator, in the thread group, we have configured 49 users. Ramp-up period in seconds is 180 seconds. We have 4 steps: login, products, access a product, and logout step. In each step, we add a delay. For example, when a login request is made, user need to some think time, some delay time, in order to access products page. And after 1 second, the user accesses products page. When the user need another think time, for example, 5 seconds, in order to access product details page. So the user needs some time in order to choose the right product. Then the user reads product details, and the think time is 3 seconds. For 3 seconds, user reads product details, notes some information, and so on. And then he performs a logout request. In a view results tree, we collect only errors. So these errors should be collected in a file, in a separate file for load generator results tree CSV. And then we need to collect response times, and these response times are collected in another file. Also, we have configured active threads over time in order to see how many threads are up. Also, the number of threads can be seen on top right corner of JMeter. JMeter graphical user interface. Also, when dealing with thread group, you need to select not continue. Action to be taken after sampler error should not be continue, but should be start next thread loop. This is a best practice, so always check this option. And we have another JMeter instance called collector. We have configured one single user, wrap-up period 1 second, and infinite number of loop count. On load generator, the various loop count also used as infinite. So we have the same number of steps, the same test script. The only difference that the errors are corrected in a different file called collector, and response times are also collected in different file called aggregate report collector CSV. And this one should be, we can disable. So let's start the test. So we are starting in this folder. Let's check the folder. So test plans, 2 instances. The folder with the log files are empty, and the log files will be created. Let's start the test. The number of active users is visible on top right corner of JMeter graphical user interface. So there are 3 from 49, 4 from 49, 5 from 49, and so on. And here we can see here in the chart the number of users loaded in the system. The number of concurrent users loaded will be the total number of 50 users will be loaded in 3 minutes period of time. So we will need to wait for 3 minutes. This is the time which is already passed. So 1 minute passed. We have 15 users loaded into the system. We can see that the log files for load generator instance are already created. So we have response times. Aggregate report is collecting response times, and results tree is collecting errors. Also, we can see the response times during in real time. So during the test, you can see this table is a bit updated. Also, we can see errors. We have no errors, so this file is empty. Also, we can see in the aggregate report, we can see number of samples, minimum response time average time, and maximum time of request. So in average, it took about 800 milliseconds for each request, and the number percentage of errors. So 2 minutes are passed. We have 36 number of concurrent users. So we can see here that there are 36, 40. Let's wait a little bit, 20 seconds till 3 minutes, and we have 45 concurrent users loaded, and it is continuing loading. The errors are fine. We have no errors, 0% for each request. Number of samples, 400 samples for each request. Okay, we have 3 minutes passed, and after 3 minutes, we are just starting collector instance. So we have one user, and this user is making requests. So we have this user is making requests. Let's wait a little bit. For example, let's wait for 5 minutes in order this user to collect the data. And after starting this one user, we can see that the log files for collector are already created. So aggregate report collector, which collects response times for collector, and results tree collector, which collects errors for collector. All this data should be included in the final test report. So this user is collecting response times after all users were loaded into the system. So we have clean results here, and here we have dirty results because these results include the ramp-up period of time. So we call it like that. And here we have clean results. So when all 50 users were loaded into the system. Let's wait 1 more minute. For example, the collector will collect data for 3 minutes, but usually the load test lasts for 2 hours. So the load test should last 2 hours. During load test, we also need to pay attention to the percentage of errors. If the percentage of errors is too high, then we need to include this information to report that the system does not support that number of concurrent users. And usually the percentage of errors should be not more than 5%, but this number should be agreed with the client. So if a client says that it should be not more than 5% or not more than 10%, and so on. We include this information into the final report. And let's say that the test is done. We need to stop collector instance. We have 2 options: shutdown and stop. Shutdown will terminate immediately, and stop will stop gracefully. And also we have errors, JMeter errors. Like here, you can monitor JMeter errors here. We have 0 errors, which is fine. For example, here could be some memory out of memory exception, and so on. So Java exceptions and so on. 0 errors. Also, we pay attention to load generator errors. So we have 0 errors as well, which is fine. So we need to stop collector first. So we are stopping it. And then we stop load generator. Okay. And after that, we include response times from collector. We include into final report, and we use load generator data only for checking for errors and so on. And now we also include these files. Also include as a performance test artifacts. We need to deliver these files to the client, and this is So let's talk a little bit about JMeter scripting best practices. Um, for best practices, we have organized following chapters like plan and design your test scenarios, organize your test plan structure, parameterize your scripts, handle dynamic content and correlation, optimize script performance, implement error handling and debugging techniques, use timers wisely, make use of assertions, optimize distributed testing, leverage JMeter plugins, configure proper load distribution, generate and analyze meaningful reports, version control your test scripts, integrate JMeter with CI/CD pipelines, and ensure script maintainability. Plan and design your test scenarios. Define clear objectives. Start by defining what you aim to achieve with your performance tests. For example, validating the application's performance under a specific load, identifying bottlenecks, and so on. Use realistic scenarios. Simulate real-world user behavior by modeling realistic test scenarios, including different user paths, actions, and think times. Determine the right load model. Decide on the number of users, ramp-up period, test duration, and load pattern, steady, spike, etc., to accurately reflect production conditions. Organize your test plan structure. In order to organize the test plan structure, we need to use thread groups effectively. Organize your test plan into multiple thread groups to simulate different user behaviors or workflows. Modularize your test plan. Use modular design principles, breaking down your test plan into reusable components. For example, create separate thread groups for different functionalities, or use transaction controllers to logically group requests. Use comments and labels. Clearly label all elements in your test plan and use comments to explain complex logic or calculations. This will make your test script easier to understand and maintain. Use CSV data configs. Use the CSV dataset config to parameterize user inputs, credentials, and other dynamic data. This ensures the test reflects real-world usage by using multiple datasets. Use variables and functions. Utilize JMeter functions like random or UUID and variables to generate dynamic values, enabling the simulation of different user sessions. Avoid hard coding values. Avoid hard coding values like URLs, credentials, and other test data directly into your script. Instead, use variables, property files, or external data sources. In order to handle dynamic content and correlation, uh, we need, first of all, we need correlation. We need capture and reuse dynamic values like session IDs, tokens, or unique identifiers. Using post processors like regular expression extractor or JSON extractor, this is essential for ensuring the script handles dynamic content correctly. We need to validate responses. We need to add assertions, response duration, response, for example, or another assertion like duration or size to verify that the server responds as expected and the dynamic content is correctly handled. Also, we need to minimize resource usage. We need to disable or remove uh, unnecessary listeners like view results tree and view results tree in table in production test runs, as they consume significant memory and CPU. In order to optimize the script performance, we also need to use non-GUI mode for load tests. We need to run load tests in non-GUI mode, command line mode, to conserve system resources and achieve more accurate results. The command for this is JMeter -n-t testplan.gmx -l result.gtel. We need to monitor memory usage. We need to configure heap size in the jmeter.bat or jmeter.sh file to match the system's capability. For example, XMS and XMX parameters. Also, we need to implement error handling and debugging techniques. For example, by using a debug sampler. We need to add debug sampler to check and verify variables, responses, and configurations. We need to log meaningful messages. We need to use log.info, log.warn, or log.error statements in JSR 223 sampler to log meaningful messages for debugging purposes. Retry on failure. Use if controllers or while controllers to implement retry logic for transient errors, such as network timeouts or temporary server issues. We need to use timers wisely. So we need to add think time. We need to use timers like constant timer or Gaussian random timer to simulate realistic user think times between requests. Also, we need to avoid overusing of timers. We need to place timers at the appropriate levels under the thread group or controller to apply them effectively, rather than duplicating them for each request. We need to make use of assertions. We need to add assertions to verify responses. For example, use response assertions to validate that the server returns the correct response. For example, status codes or response content. Even better, it is recommended to validate not only status codes and response content, because it can happen that the server returns a correct status code, but the content is broken. Also, we need to avoid excessive assertions. Only add necessary assertions to avoid adding excessive processing overhead to your test. Also, we need to optimize distributed testing. We need to configure master and slave nodes properly. When running distributed tests, ensure that all nodes, master and slaves, are correctly configured and that the JMeter versions match. Limit network traffic. Disable data-heavy listeners in distributed mode and use backend listener to send results directly to a centralized storage, for example, InfluxDB, Prometheus. In order to develop our test scripts correctly and respect the best practices, we need to take into account we need to leverage JMeter plugins. Use plugins to enhance capabilities. Explore JMeter plugins like custom thread groups, composite graphs, or dummy sampler to add functionality not available in core JMeter. Keep plugins updated. Ensure plugins are updated to their latest versions to avoid compatibility issues and benefit from new features. Configure proper load distribution. Simulate different user loads. Use constant throughput timer to control the request rate and simulate various user loads realistically. Avoid overloading a single machine. Spread the load generation across multiple machines if you need to simulate a high number of users. Also, generate and analyze meaningful reports. Enable useful listeners for reporting. For example, we need to use a summary report or aggregate report or HTML report for meaningful test result visualization. Automate reporting. Use JMeter's built-in report generation or integrate JMeter with CI/CD tools to automatically generate reports after each test. Version control your test scripts. Use version control. Store JMeter scripts in a version control system like Git to track changes, collaborate with team members, and maintain script history. Document changes. Keep a change log for your scripts, documenting major updates, configurations, and versions of the application under test. In order to integrate JMeter with CI/CD pipelines, we need to automate. For this, one step is to automate test execution. Integrate JMeter tests with CI/CD tools like Jenkins, GitLab CI to run tests automatically on each build or deployment. Use command line execution. Leverage JMeter's command line interface for seamless integration with automation tools. Ensure script maintainability. Use descriptive names. Use meaningful and descriptive names for samplers, controllers, and other test elements. Document your test plan. Maintain comprehensive documentation explaining the test objectives, scenarios, configurations, and scripts for future reference. Also, all these are called as test artifacts and are used in comparing results with future test runs or previous test runs, which is also called as benchmarks. In summary, following these best practices will help you create efficient, scalable, and maintainable JMeter scripts that provide reliable performance testing results. Proper planning, organization, parameterization, and optimization are crucial to maximizing the value of your performance testing efforts with JMeter. So today we will talk. Now we will talk about a thread group, special options of a thread group, and we will talk about setup thread group and tear down thread group. We have created a basic test scenario with 4 steps and with some delay between steps. I have set a delay of 1 second. We have a view results tree at the level of test plan and aggregate report and active threads over time. We need to set. Now let's analyze about special options of a thread group. For example, we already know about the number of threads option, ramp-up period, and loop count, where you can set a constant or infinite, and so on. Let's talk about thread lifetime options. If we tick this option, we have presented 2 options like duration and the startup delay. For example, let's specify duration. This is the duration of a test, the overall duration, not of the test, but only duration of a thread. Because the test could last 2 hours, but the ramp-up period could be 30 minutes. So, for example, let's say that let's set a duration of 20 seconds, and startup delay will be 0. And let's start this test. So the thread started immediately, and its duration should be 20 seconds. So let's see if so the duration is 20 seconds. And now let's set the startup delay to be 20 seconds. No, for example, 10 seconds, and the duration should be 20 seconds. Let's clear the results. Just press Ctrl E. Let's start the test. So a 10 seconds delay, and when the thread started. Let's stop the test. The test is stopped. Okay. And now I just wanted to say that we need to set a view results tree at the test plan level, so here, and not on a thread group level, because if we set at a thread group level, we will not see the results for a setup thread group and tear down thread group. So we have a view results tree at a test plan level, and now let's set loop count to be 1. Let's clear results, and let's test setup thread group. So we are enabling the element. You can just see that we have only one step in setup. We have a precondition request, a basic request, and usually the loop count should be 1 for a setup thread group. You can set any number of threads. I will use 1 thread, ramp-up period 1 second. You can also see the documentation for the setup thread group by pressing right-click and help, and you will be redirected to the online documentation on the Apache JMeter site, so you can read about this element. And now I have enabled this element. I have enabled the thread group, only one user, one loop, and let's clear results and let's start the test. As a result, you can see that a setup thread group is run before any other regular thread group is run. So all the requests will be run before the regular thread group. So this is why a precondition request, so this request from the setup thread group was run before any other request, any other ordinary request. So we have a login here, login requests like login, product list, product details, logout, and before them a precondition request was run. And now let's test the tear down thread group. So tear down thread group, the requests are run in tear down thread group. The requests are run after regular thread groups. So I have disabled setup, I have enabled tear down thread group, and let's clear results and let's see if as a result you can see that the post condition request was run, after regular requests from the regular thread groups. A post-condition request is the request from the teardown thread group. And now let's enable both, so you can see that both requests are run. So the precondition is run first, then follow regular requests, and post-condition request is run as well. So let's talk a little bit about stepping thread group. A stepping thread group is a special type of thread group in JMeter that allows for more granular control over how virtual users' threads are ramped up, maintained, and ramped down during a test. This thread group is particularly useful when you want to simulate a load test with a gradual increase in the number of users, rather than starting all threads at once or following a simple linear pattern. Key features of stepping thread group is a gradual ramp up. You can specify the number of threads to start initially and then gradually increase the load in steps, which helps to monitor how the system behaves under increasing load. Hold time. After reaching the desired number of threads, the group can hold that load for a specified duration, allowing you to see how the system handles a steady load. Ramp down. You can also configure a gradual ramp down, allowing threads to stop in steps rather than all at once, which helps to observe how the system behaves when the load is reduced. So how to install the stepping group? So we need a plugin manager, and then we need to install extra set. After installing it, you will be the stepping thread group will be available in JMeter. I will show a case how to use a step group. So when to use, we will return to this chapter later. So let's install the extra set. So we are going to plugins manager, available plugins, extras. Set stepping custom stepping thread groups. This is a custom thread groups. Apply changes and restart. Okay, so we have installed a custom thread groups. So this one, custom thread groups plugin. So let's see if stepping thread group is available now. So we are right clicking and we are going to yes, and this is a stepping thread group and ultimate thread group. Let's see stepping thread group. So we are presented with a chart how these threads are going to be started. So we are setting, as a best practice, we are setting start next thread loop. Action to be taken after a sampler error should be this option, and we are specifying number of users. This thread group will start. So this is an initial delay. Then we need to start. So 0, then next add 10, 10 threads every 30 seconds. Using ramp up, so these 10 threads will be ramped up in 5 seconds. Then hold the load for 60 seconds. So this is this one, and finally stop 5 threads every second. So this is the tear down strategy. We can specify here to the load, hold the load, for example, to 80 seconds, and this is changed. So you can see this step is changed here. And we can specify adding, for example, 5 thread groups every 30 seconds. So the number of steps is increased. We can specify 20 threads. So we have 1, 2, 3, 4, 5 levels. If we specify 10, we have 10 levels of increasing. Let's specify 20, for example. So all the users will be ramped up in 2 minutes and 30 seconds. If we specify to add 10, so the ramp up period will be greater, will be 5 minutes, about 5 minutes. Let's specify 20 users every 30 seconds, so the ramp up will be shorter. And now let's use this thread group. We can just copy the elements into this thread group, into stepping thread group. Let's disable the thread group. And we have active threads over time listener, we have results tree, and aggregate report. For the results tree, we are specifying to log only errors in order to not overload the JMeter instance. These 2 elements, we will remove them. This one should be removed, and we are saving the test plan as a stepping thread group. Okay, the test plan is saved, so we are checking once again that everything is correct. And let's see this in action. Let's start. So 20 users are loaded. So then we need to wait for 30 seconds. We are waiting for 30 seconds. After about 30 seconds, next 20 users are loaded into the system. So we can see the total number of users in the top right corner of JMeter. You can see 40 from 100. We have 0 errors, everything is fine. View results tree have not logged any errors. In aggregate report, we have minimum, average, maximum, and error percentage. The error percentage is 0. You can see the number of requests which are made, the total number of requests which are made. Okay, after 30 seconds, the next 20 users are loaded. So we have 60 users loaded into the system. So the ramp up period of these 20 users is 5 seconds. So this parameter. We have 80 users currently loaded into the system. and we have one level, second level, third level, fourth level, and now will be appear the last, I guess the last level. So we have all 100 users loaded, so you can see from the chart, from the active thread groups, threads over time chart. So, and here we have 80 seconds should so 1 minute and a half should be performed the load test. So we are holding all 100 users for 1 minute and a half. So this is this parameter, and then we stop threads gradually. And the threads are tearing down. So you can see the number of threads, active threads, is decreasing, and the step is the test is stopped. So you can see the test is stopped. Let's see aggregate report. Let's check it. Let's check for response times, the errors, the number of requests, 10,000 of requests, 2,500 of requests for each request, and the results tree is 0 errors. And so, and let's increase the step of let's increase the stage of ramping up every 20 users. So let's increase not in 5 seconds, but let's specify this just not 5 seconds, but for example 20 seconds. In order to not to stress the system, usually the ramp up period should be more. And okay, let's clear results. The results are cleared. Save test plan, and let's run once again. So you can see that the users are ramped up in 20 seconds instead of 5 seconds. Okay, the users are loaded, so then 30 seconds is the users are working, and after 30 seconds the next level of ramping up should occur. Okay, this one is tested. We are just stopping the test. So when to use stepping thread group, the stepping thread group is used usually in a stress test. So you need to test when the system is breaking. As I told, the system is breaking by usually counting following factors. For example, following information like the number of errors is just too big, or response time is response time is too big, or you have some counters like CPU, memory, and disk on the servers, on the environments. If these counters are reaching 100% and are reaching the limit. Let's talk a little bit about thread groups. So here we have a list of available the most popular thread groups in JMeter. Related to the basic thread group and stepping thread group, you already know about these thread groups. But we have some other thread groups like Ultimate. For example, a little bit about basic thread group. This is a default thread group in JMeter. It is used to simulate a fixed number of users, threads who perform a set of actions, requests. Testers can specify the number of threads, users, the ramp-up period, time taken to start all threads, and the loop count, the number of times each thread will execute the test script. This thread group is ideal for basic load testing scenarios where you want to observe how the system handles a steady number of users. And stepping thread group, you already know this thread group. It allows more granular control over how users are added to the test over time. It enables the gradual ramp-up of threads in steps rather than all at once. Testers can specify the initial number of threads, the increment rate, number of threads added after a specified time interval, and the hold time, duration for which the threads will continue running. This is useful for observing system behavior under steadily increasing load and identifying breaking points. And the new thread group, which is called the Ultimate thread group. The Ultimate thread group is designed to provide ultimate flexibility in configuring the user load over time. It allows testers to define multiple stages, each with a different number of threads, ramp-up time, and hold time. This makes it perfect for complex load patterns, such as simulating sudden spikes or drops in user load. The ultimate thread group is often used in stress testing, where the aim is to determine the maximum capacity of the system. Concurrency thread group. The concurrency thread group focuses on achieving a target concurrency level. Testers specify the target number of concurrent users and the ramp-up time to reach this level. The group dynamically adjusts the number of threads to maintain the specified level of concurrency throughout the test. This is particularly useful for testing scenarios where maintaining a consistent level of user concurrency is critical, such as ensuring the system's performance remains stable under a constant load. Arrivals thread group. The arrivals thread group allows you to control the rate at which new users arrive in the system, rather than the total number of users. Testers specify the number of users arriving per second and the ramp-up time to achieve that rate. This is ideal for scenarios where you want to simulate a steady stream of users arriving at different rates, such as e-commerce websites during a sale event or a sudden influx of traffic. Free-form arrivals thread group. So free-form arrivals thread group is an extension of the arrivals thread group, offering more flexibility. It allows you to define a custom schedule of user arrivals over time, including different stages with varying arrival rates. This is useful for highly customized testing scenarios where the user arrival rate is unpredictable or varies significantly during the test period. Burst thread group. The burst thread group is designed for scenarios where you want to simulate short bursts of high traffic. It allows you to define a burst of users arriving at the system over a very short period of time, followed by a period of low or no traffic. This is useful for testing systems that need to handle sudden high load spikes efficiently, such as online ticket booking systems during a flash sale. Open model thread group. So open model thread group is used to model a scenario where new users continue arriving over time without a predefined limit on the total number of users. It is useful for modeling real-world scenarios where users keep joining the system, such as a web application that receives a constant stream of new visitors. This thread group focuses on the rate at which new users are added and the system's ability to handle ongoing load without collapse. Teardown thread group. The teardown thread group is used to perform cleanup operations after the main test execution is complete. It runs after all other thread groups have completed their execution. This thread group is often used to clean up resources, close connections, or perform any final operations that should only occur after main load testing scenarios have finished. Unlike other thread groups, it does not contribute to the actual load on the system. Custom threads, custom thread groups through plugins. JMeter supports a variety of custom thread groups through plugins available in the JMeter Plugins Manager. These plugins extend the functionality of core thread groups to support specialized testing requirements. For example, the throughput shaping timer plugin allows users to control the throughput rate, while the basic timer allows more customized timing control over thread execution. So also about a little bit the teardown thread group, you already know about this thread group. So all these thread groups provide the JMeter users with a wide range of options to simulate different types of load conditions and real-world scenarios, allowing for comprehensive testing of applications and systems. So let's speak a little bit about timers and the best practice how to use timers in JMeter. You can use the most popular timers are the constant timer and uniform random timer. So constant timer and uniform random timer. Constant timer is setting the constant delay, and uniform random timer is using a seed. Like you can use a random delay maximum and the constant delay offset. And constant delay offset it is clear that it is constant delay, and constant delay is adding with random delay maximum. For example, if we specify 10 seconds, so 10 seconds random delay maximum, it will be generated from 0 to 10 seconds, and this number will be added with constant delay. So if you, for example, let's say that you run on the tests on by using your machine, and your machine is used by generating requests to target servers. So your machine in this case is called a load generator machine. It is if your load generator machine, it is recommended that you need to monitor counters on the load generator machine, for example, like CPU, memory, and disk I/O, and so on. If you notice that your load generator machine has some bottleneck, for example, a CPU bottleneck or memory bottleneck, and so on, you can improve your test scenario. You can improve your test script. For example, let's say that you use the constant timer, constant timer in your scenario, and you have set these timers at a request level. For example, step 1, step 2 think time is 2 seconds, and for step 3 think time is 4 seconds. So your scenario will be executed, so it will be executed first request, then it will think for 2 seconds, then it will execute the second request, then it will think for 4 seconds, and it will execute the third request. And if you notice that your script is too complex and your law generator machine is not so good, you can improve your JMeter script. You should set, the best practice says that you should set these timers not at a request level, because this is taking much more computing power, and you can set these timers at a thread group level like this, and you just delete or disable the timers at request level. So you, instead of using 3 or 10 timers for a test scenario, you will use only one single timer, and which is much less complex and much easier and less and better to understand for a JMeter script, and better to execute for a JMeter script. So you can use a constant timer, like setting an average delay, for example, let's say 3 seconds, and it will be executed so that it will be executed first step, then think time 3 seconds, and then will be executed second step, then again think time 3 seconds, and then will be executed the third step. And you can use also can try to use, instead of constant timer, in order to simulate much more user realistic scenario, you can use, instead of constant timer, you can use a simpler timer, uniform random timer at the thread group level. So you just disable the constant timer at the thread group level, and you use a uniform random timer at the thread group level, which is improving your test script to be much more realistic. For example, the delay will be 3 seconds plus a random seed, which will be from 0 to 5 seconds. For example, a random seed will be 2.5 seconds, and these 2.5 seconds will be added with 3 seconds. In total, 5.5 seconds. So let's talk a little bit about assertions. Assertions in JMeter are used to validate the responses returned by your test scripts against expected outcomes. They help to ensure that the server response contains the correct data, meets performance requirements, and behaves as expected under load. By using assertions, you can automatically verify that your application works correctly and meets the specified performance criteria. We have following assertions in JMeter. The most used are, for example, response assertion. The response assertion is the most commonly used assertions in JMeter. It allows you to verify that the response received from the server contains or matches a specific string, text pattern, or a regular expression. You can use this assertion to check for the presence of, for example, for the presence of a text, words, or patterns in the response body, headers, URL, or message. The response assertion is used for validating the content of the server response, such as checking for error messages, confirming that the page loads correctly, or ensuring that specific elements are present. The common use cases for a response assertion is to verify that a web page contains specific text or elements, to check for the absence of certain error messages, ensure that JSON or XML responses contain the expected data. The next assertion is duration assertion. Duration assertion is used to ensure that the server response time is within a specified limit. It allows you to set a maximum time in milliseconds that a response should take to be considered successful. If the server takes longer than the defined duration, the assertion will fail. This is particularly useful for performance testing scenarios where you want to ensure that the application meets specific response time requirements. Common use cases for duration assertion are following: to ensure that the response time for a particular request does not exceed a certain threshold, and to validate service level agreements, SLAs, related to response times. The next assertion is size assertion. Size assertion checks the size of the response against a specified condition. You can use this assertion to verify that the size of the server response in bytes falls within a certain range or matches a specific value. This can be useful for ensuring that the return data is neither too large, which could indicate a problem such as excessive data being sent, or too small, which could indicate missing data. Common use cases are verify that an image, file, or data stream has the correct size, to check that the response size is within an acceptable range. The next assertion is XML assertion. The XML assertion validates that the server response is well-formed XML. This assertion checks whether the XML response conforms to the correct syntax and structure. It does not validate against a specific schema, but ensures that the XML response is correctly formatted. This is useful for testing web services, RESTful APIs, or any application that returns XML data. Common use cases are, for example, to validate that an API or web service returns a well-formed XML response, to check for proper nesting, closing tags, and correct XML syntax. The next assertion is XPath assertion. The XPath assertion allows you to validate the XML response using an XPath expression. This assertion checks whether a specified XPath expression is present or matches a specific value within the XML response. This is particularly useful when testing web services or APIs that return complex XML data structures. Common use cases are, for example, to verify specific nodes, attributes, or values in an XML response, to check for the presence or correctness of specific XML elements or attributes. JSON assertion. The JSON assertion is used to validate JSON responses by checking the content against specific values, structures, or patterns. You can use this assertion to verify a JSON response contains expected values or matches a specific structure, such as checking for the presence of keys, values, or nested objects. This is essential when testing APIs or web services that return data in JSON format. Common use cases. Validate that a RESTful API returns the correct JSON structure and values, and to check for the presence of specific keys or values in a JSON response. HTML assertion. The HTML assertion checks that the server response is a valid HTML page according to the Web3C, World Wide Web Consortium standards. This assertion uses gtidy, a Java library that analyzes HTML content for common errors like missing tags, improper nesting, or broken HTML. It is particularly useful when testing web applications to ensure that pages are rendered correctly in different browsers. Common use cases are, for example, verify that HTML pages returned by a server are valid and error-free, ensure compatibility across different web browsers by validating HTML structure, and so on. The next assertion is MD5, hex assertion. This assertion is used to validate the MD5 checksum hash of a server response against a specified value. It helps ensure data integrity by checking whether the content of the response has changed. This is particularly useful when testing file downloads or ensuring the consistency of static content. Common use cases, for example, verify the integrity of downloaded files or static content. ensure that the server response has not been altered or tampered with. Bean shell assertion. Bean shell assertion provides flexibility to write custom assertions using bean shell scripting. Bean shell is a lightweight scripting language compatible with Java, allowing testers to create complex, customized validations that go beyond the capabilities of built-in assertions. This is ideal for scenarios where standard assertions do not meet specific testing needs. Common use cases, for example, to perform complex logic or calculations as part of the validation process. Implement custom validation rules that are not covered by other built-in assertions. And the compare assertion via JMeter plugins. The compare assertion is an assertion that plugin available through the JMeter plugins manager. It allows you to compare two responses, such as checking if the response from a cache is the same as the original response from the server. This is useful for testing cache mechanisms, mirroring or comparing responses between environments. Common use cases: compare responses from different servers or environments, and verify cache performance by comparing cached and original responses. These popular assertions provide JMeter users with powerful tools to validate server responses, ensuring that the application behaves correctly under load and meets performance criteria requirements. By using these assertions, you can detect issues early in the testing process and ensure that your application is robust, reliable, and ready for production. Let's talk a little bit about response assertion. The response assertion is one of the most commonly used assertions in JMeter, and it is designed to validate that the service response meets specific criteria. By using response assertion, you can ensure that the application under test returns the expected output, such as specific text, pattern, or data structure. This is crucial for both functional and performance testing to verify that the application behaves correctly under different load conditions. Key features of response assertion is versatile matching options. The response assertion allows you to check various parts of the response, such as the response text, response code, response message, headers, or document, response body, and document size. Also, multiple conditions. You can add multiple conditions to a single response assertion, making it possible to perform complex checks. Regular expression support. Response assertion supports the use of regular expressions for pattern matching, which enables flexible and powerful validations. Customizable matching rules. You can customize how JMeter should apply the match. For example, contains, or matches, or equals, or substring, and so on. So, how to configure response assertion? You just need to click, for example, we have a sampler. Let's enable the sampler, and you can click on the sampler and add assertions, response assertion. Or you can have, for example, you can have a transaction controller. Let's set transaction controller. So thread group, as you see, you can't add. You also can add assertions, but you can add the assertions to transaction controller as well. Add sampler and assertions and response assertion. In the response assertion panel, as you see, we have various fields. So we have field to test, which can be, for example, text response, which validates against the entire response body. We can have response code, checks the HTTP status code, for example, 200, 404, response message, verifies the HTTP response message, for example, OK or not found, response headers, validates content in the response headers, and URL sampled, checks that actual URL that was requested, and document response size. Response we can define different pattern matching rules as well. So you have contains, matches, equals, substring, and not. Contains checks if the response contains the specified pattern, substring. Matches checks if the response exactly matches the pattern using regular expressions. Equals verifies if the response is exactly equal to the given string. Substring checks if the response contains the specified substring, and not inverts the match condition. For example, it fails if the pattern is present. Let's set contains text response, and we can specify the patterns to test. We can specify one pattern, but we can specify multiple patterns. So you can add the multiple patterns as well. So let's add and we can test different scenarios by using the response assertion. For example, we can validate that response contains specific text. We need to choose text response, contains, and we can test, for example, if login was successful. So we need to test if response returns the corresponding message. For example, login successful. And we are using Blaze demo request on blazedemo.com. Let's disable this assertion, and let's make one request. As you see, it returns HTML, which contains different elements, but this HTML page does not contain login successful message. So if we enable the assertion and run the test with assertion, it will fail. But we can test, for example, if it contains one option, for example, let's see if we can find some text. For example, the word Boston in its body. Okay, let's clear the test. Let's run once again, and the request is passed. So, and for example, if you modify, for example, Boston 1, it will fail. It should fail. So that's how it works with text response and contains. Another scenario would be to check for correct HTTP status code. For example, I have added one additional session, this one. I have checked response code. I have checked the equals, and here I have specified 200. Let's enable assertion. Let's clear results, and let's run once again. It is passed because the response code is 200. And let's test, for example, 201. And this request should fail. It has failed because the actual response was 200. Okay, let's disable this response assertion. And another scenario would be to verify the absence of error messages on the page. For example, I have checked text response contains error, and I have checked as well the not condition. So this should sound like the text response should not contain error message on the page, on HTML page. And let's run this. Let's clear results, and let's run with one thread, and the actual page, HTML page, does not contain the error in its as a response. For example, if you search for error, we can't find it, and that's why the corresponding request was passed. Let's disable, and we have. Let's disable Blaze demo request, and let's enable JSON request. This request points to JSON placeholder typecode.com. This is test server, and we are pointing to posts path. This is a GET request and HTTPS protocol. So let's test without assertion. Let's make a simple request. So this is the request, and as you see, the response body contains JSON. In order to test, for example, if there is some element, JSON element returned, you need to check the response text contains, and to use regular expression. You can check contains or matches. Let's check contains, and I am checking that there is a key value pair like user ID as a key and value some integer number. As a response, in the response, you can see that there is such a key value pair, user ID 1, and so on. So let's clear results, and let's check if the request is passed. So the request is passed. Let's modify this condition. For example, if it has some user ID 2 key, let's run this request, and the request is failed. Let's check that there is user ID with small letter. The request should fail. So you can see that the request is failed. And if we correct this one to the correct value, user ID, the request should be passed. So the request is passed. Best practices for response assertion. So use specific matching rules. Choose the most specific matching rule possible, equals or matches, rather than generic rules, contains or substring. This reduces the likelihood of false positives. Optimize regular expressions. Use efficient and concise regular expressions to minimize performance overhead. Avoid complex patterns that are computationally expensive. Limit the scope of assertions. Apply assertions only to relevant samplers or parts of the response. Overusing assertions can lead to increased processing time and reduce the performance of your load tests. Test multiple conditions. Combine multiple conditions within a single response assertion to reduce the number of assertions and improve readability and performance. Monitor assertion failures. Use JMeter's View Results Tree listener to monitor assertion failures and identify issues in your test. Failures could indicate functional issues with your application or flaws in the test script. Use assertions judiciously. While assertions are important for verifying test correctness, excessive use of them, especially complex ones, can slow down the test execution and burden the load generator. Use assertions sparingly and focus on critical validation points. As a summary, the response assertion is a versatile and powerful tool in JMeter to validate server responses against expected outcomes. Properly configuring and optimizing response assertions can help you ensure that your application behaves correctly under different load and while minimizing the performance impact on your load generator. By strategically using assertions, you can detect errors early in the testing process, ensuring the robustness and reliability of your application. So let's test with response assertion by using multiple conditions check. We are having Blaze demo request, a sample request. Then let's do a test with one single user, and let's check what response comes when it from HTML response with one single user. So we need to check multiple texts on the page. For example, let's enable the response assertion and let's check, for example, Boston. Then we have San Diego, and these are option values. So we can add some patterns to test. You can add them as multiple as you want, but keep in mind to not add too much because on executing the tests it will add the load to your load generator machine. But you can use JMeter in automation. So you can use JMeter by running a test with a single user. When you are running the test with a single user, it is called as using JMeter in automation. If you are planning to run with 1,000 or 100,000 users and so on, you need to take into account that you to not add too much checks. So we are checking, for example, for option values, but we can check, for example, for a text on a page. For example, this one, this header. Let's add this header as well. And let's run. So the request is passed. And let's change at least one value. For example, Mexico City 2. And if at least one value is failed, it will fail the request. The request is failed, and when you expand and when you read the error message in the response assertion, you can read that assertion error is false, assertion failure true, and you can read the message: the test failed, text expected to contain Mexico City 2. So it returns as an error only this row. The first row, second row, and the fourth row is passed. So if it is failed, it will mention only the third row. Let's talk a little bit about a duration assertion. In order to add a duration assertion, you need to right-click on request sample and add assertions and choose duration assertion. A duration assertion in JMeter is a type of assertion that checks whether the response time of a request is within a specified time limit. It's particularly useful for performance testing scenarios where you want to ensure that your server responds to requests within an acceptable time frame, such as meeting the requirements for a service level agreement, SLA. How duration assertion works? The duration assertion checks the time it takes to receive a complete response from the server for a particular request. If the time taken exceeds the specified duration, the assertion will fail, and JMeter will mark the result as a failed sample. So it asserts the duration of a response, which the duration of a response could include both network latency and uh, the processing time in order to process the request and send the response back. It's a simple assertion. You have such fields like name, comments, and you apply to field which you can choose between sample and subsamples, main sample only, and subsamples only, and the duration in milliseconds. Um, let's talk a little bit about practical tips. Uh, Set realistic limits. We need to choose a duration that reflects the acceptable performance criteria for our application. If we set it too low, we might get a lot of false positives. For example, failed assertions that are not actually indicative of a problem. And we have such combined with other assertions. You can use duration assertion alongside other types of assertions like response assertion or size assertion to create a more comprehensive test scenario. And monitor performance trends. Use duration assertion to monitor how response times change under different loads or conditions. It helps in identifying performance degradation. And analyze failures. When an assertion fails, analyze the reason for the delay. It could be due to network latency, server processing time, or other factors. So let's test this duration assertion. In order to test it, I will disable it for a moment, and we'll save a test plan, and we'll run a short test with one thread. And this is needed in order to check the response time of a request. So it is 1 second. Let's check once again. We will add aggregate report, and we'll run once again. Yes, it is in average it is 700 milliseconds, so 0.7 seconds. So let's set the duration assertion to be, for example, 1 second. And if we set it 1 second, thus the request is passed. So let's set it 0.5 seconds. And let's run once again. And as you can see, the request is failed. So duration assertion is a simple yet powerful tool in JMeter for ensuring that your application's performance meets the required standards. It helps you quickly identify and address any performance bottlenecks that could impact user experience. So let's talk a little bit about size assertion. Size assertion is a type of assertion that is used to validate the size of a response received from a server. This assertion checks whether the size of a server's response is within a specified range or matches a specific size. It's useful for verifying that the response data is not too large, indicating an unexpected payload, or too small, indicating missing data. How size assertion works? Size assertion works by comparing the size of a response body measured in bytes against the conditions you specify. If the size of the response does not meet the specified criteria, the session will fail, and JMeter will mark the test sample as failed. So in order to add the size assertion, you just need to right-click on request, add assertions, and choose size assertion. It has different has different fields like type of comparison and size in bytes. In order to set the value of this field, let's disable the size assertion and we'll run a quick test. And let's see the size. So the size in bytes is 5000, and let's enable it, and let's set, for example, 6000 bytes, and let's set it less than or equal to 6000. So in this case, the request should pass. So let's run the test once again. The request is passed, and if we choose to be more than or equal, it is expected that the size to be more than or equal to 6000, and the request will fail. So let's run the test once again, and as you can see, the request is failed, and in the size assertion it is saying that the result was the wrong size. It was 5000, but should have been greater than or equal to 6000 bytes. Okay, and let's talk a little bit about size assertion practical tips. So determine reasonable size limits. We should analyze the typical size of the responses and set realistic limits for assertions. For example, know the average response size of your API or web page to set sensible thresholds. Also, we need to combine size assertion with other assertions. We need to use the size assertion alongside other types of assertions, such as response assertion or duration assertion, to create more comprehensive tests that check both the content and performance of your application. Use for different scenarios. You can apply size assertion in various scenarios, such as checking if the responses have been truncating, detecting data corruption, or verifying that the service sends expected content size. Also, you can monitor different types of content. Use size assertion to monitor both text-based content like HTML, JSON, or XML, and binary data like images, videos, or file downloads. So size assertion is a useful tool in JMeter for ensuring that the size of a service response falls within expected limits. It can help detect anomalies in data transmission, such as missing or extra content, by validating the response size. For more effective testing, it is best used in conjunction with other assertions that validate different aspects of service response. Let's talk a little bit about XML assertion and XPath assertion. So I have created a simple test plan, and we have, for example, first request is simple request to blazedemo.com. This is an HTTP request, HTTP GET request, and I have used XPath assertion. In order to add it, you need to choose Add Assertions, and here is the XPath assertion. XPath assertion is a component in JMeter that is used to validate XML responses returned from web service by leveraging XPath expressions. XPath, XML path language, is a query language designed for navigating and selecting nodes from XML document. In JMeter, XPath assertion ensures that the XML response matches the expected content, structure, or values. So purpose used to verify that the XML response contains the expected data, structure, or specific values. Application typically applied to HTTP request samplers that return XML or HTML content, ideal for testing web services like SOAP, REST APIs, and any application that sends XML data. So it has a XPath expression. This is the XPath assertion relies on XPath expression to specify the element, attribute, or value within XML that needs to be checked. It supports a wide range of XPath functions such as contains, starts with, and so on to create complex validation rules. So it has a name, comment, the standard fields. It has XPath expression. This is the query used to locate and validate the target element or value in the XML response. Tolerant parser, for example, when enabled, the parser will ignore the XML errors such as missing closing tags. Namespace awareness, if enabled, the XPath expression will account for XML namespaces. Negate, so inverts the assertion logic so that it passes if the XML expression is not found. And the expected validation, it is the expected outcome that JMeter will check against the response data. So I have checked for this option, XPath expression, and this option should contain a text Paris. Let's make a simple request without this XPath assertion, and I will demonstrate to you that this value. For example, we have this option, and the text should be Paris or some other option and so on. And for example, let's enable this XPath assertion. Let's clean the results and let's run the test once again. And you see that the request is passed, and there is such option with value Paris. And for example, let's say we check this option for value Paris 2, and the request normally should fail, so it fails. And you can see that the message says that no nodes matched option with text Paris 2. Okay, let's disable this request. And there is another request. For example, the first request was a simple request, a simple GET request, HTTP request to blazedemo.com website. And the second request is a simple SOAP request. In a SOAP request, you need to choose the post method. You need to specify the server name or IP, and you need to specify the path to the web service. Also, when specifying post, you need to specify in the body data, you need to specify the data to be sent as a post data. So this is the request to the web service. This is how a normal request to web service looks like. So it sends some data in the body. Also, as a header, I have specified content type to be text XML, and I have used XML assertion. This is another type of assertion which checks that the response should be in XML format. And let's disable both of them, and let's make a simple test. So in the response data, as you see, there is an XML format of the data. This is SOAP envelope, SOAP body, and the corresponding elements. Let's enable this XML assertion, and it should pass. It checks that the format of the response is an XML format. Yes, it is passed. And Also, here in XPath expression, for example, you can specify the option to use tidy. This is tolerant parser, and you can specify the corresponding XPath expression. Also, for any of these elements, the help is available on so you can see the help is available on website Apache JMeter's documentation. Also for the XPath assertion as well. So use tidy. This is tolerant of XML, HTML errors. So let's talk a little bit about logic controllers. In JMeter, logic controllers are used to define the order of processing of samplers or requests or other test elements. They help you manage the execution flow of your test plan, allowing you to simulate complex user behavior by controlling how and when different actions closely mimic real-world user interactions. Types of user controllers. We have here are the most common logic controllers in JMeter. Simple controller acts as a container to organize other test elements. It does not affect the execution flow, but helps in structuring your test plan by grouping related elements together. Loop controller repeats a set of test elements a specified number of times or indefinitely. You can use it to simulate repetitive actions by a user, like clicking a button multiple times. Once only controller ensures that its child elements are executed only once per thread during the test. Useful for actions that should only happen once, like logging in at the beginning of a test. If controller executes its child elements only if a specified condition is met, it allows you to add logic to your test, such as if user is logged in, then proceed. While controller repeats its child elements as long as the specified condition evaluates to true. It is useful for scenarios where actions should be repeated based on a dynamic condition, like while the server responds with status code 200 and so on. For each controller, it iterates through a set of variables executing its child elements once per variable in the list, often used in conjunction with JMeter's regular expression extractor to loop through dynamic values extracted from a response. A switch controller executes one of its child elements based on a specified value or index, useful when you want to choose between multiple actions dynamically. A random order controller. So runtime controller, this is the next controller, runs its child elements for a specified amount of time rather than a number of iterations. This is helpful when you want to test a scenario over a fixed time duration rather than repeating a set number of times. Throughput controller. This controller controls the percentage of iterations in which its child elements are executed. For example, you can set it to execute its child elements only 20% of the time, simulating a scenario where a certain action happens less frequently. Transaction controller. This controller controls the percentage. This controller is used to measure the overall time taken by a group of requests. It wraps multiple requests and treats them as a single transaction, providing the total response time for the transaction. The next controller is include controller. allows you to include an external test plan or fragment of a test plan into the current test plan. Useful for modularizing and reusing test scripts. Interleave controller executes one of its child elements in each loop iteration in a round-robin manner. Useful for simulating the users who perform different actions randomly. A random controller, similar to the interleave controller, but selects a child element to execute at random rather than in order. Adds randomness to your test scenario. A random order controller executes all its child elements, but in a random order each time. This is useful when you want all actions to occur, but want to introduce variability in the sequence. Also, we have example use cases. So we have example use cases of logic controllers, like login and browse scenario. We can use once only controller for the login request, so it happens just once for per user. Follow it with a loop controller to repeatedly browse different pages. Conditional testing, use an if controller to perform specific actions only if a certain condition is true, like checking if a user is an admin. And the use case of performance testing with time constraints. Use a runtime controller to perform a set of actions for a specific duration to simulate a time-bound load. And benefits of using logic controllers, like flexible test scenarios, allows you to design complex user interactions. Modular design makes test plans more organized and easier to manage. Reusability, common test patterns can be reused across different parts of a test plan or different test plans. And conditional execution enables dynamic test behavior based on runtime conditions. So let's talk a little bit about loop controllers. So a loop controller in JMeter is a type of logic controller that allows you to run its child elements, for example, samplers or other controllers repeatedly for a specified number of times or indefinitely. This controller is particularly useful when you want to simulate repetitive user actions or load patterns, such as user performing the same task multiple times. How the loop controller works. The loop controller executes its child element sequentially in each iteration. Once it reaches the end of the child elements, it starts again from the beginning until the specified loop count is reached. The behavior of loop controller can be customized using its configuration options. So when adding a loop controller, for example, you just click on an element, click add logic controller, and choose if loop controller. So logic controller and loop controller. So loop controller has a loop count option, which you can specify an integer, for example, 1 or 5 times or 10 times repeat times, or you can specify infinite number of times. Infinite number, you just need to avoid such infinite loops. Instead, you can specify the number, or you can specify a variable which comes from previous request, or which comes from a test plan configuration. For example, you can have such variable name, for example, var1. var1 is a variable name, and this var1 could come from, for example, from a previous request, from, for example, for post processor, like a regular expression extractor. For example, you're extracting some value from a page, from the page itself, and you name this variable as var1, and you use, for example, such kind of a regular expression or some regular expression in order to extract it, or this can come from a post processor, from previous requests post processor, for example, bean shell post processor, and you can have here some logic, some script, and in this script you can create variables and you can assign to this variable some value, and then specify this variable into a loop controller. Or you can have, for example, at a test plan level, you can have some kind of config elements like user-defined variables, and you can declare here some kind of variable and a value for it, for example 10 or something else, and this is a constant variable. Okay, so let's see how let's disable this one and let's see how it works. Just for example, I can specify one time. In this case, all the requests will be executed inside the loop controller will be executed only a single time. And okay, let's run this test and let's see the results. So login request, this is single request, and then only once it is executed the corresponding request. And when the thread cycle is beginning again, and it executes continuously the same script. Let's stop the script execution, and let's set, for example, here number of 2 as okay. Let's stop the test, and as you can see, um, the these 3 requests are executed once and then again second time, and when the script the script cycle begins again, and the thread executes the same script once again. That's because I have set here infinite number of times, and let's set it to 1 in order to see how it behaves. So if I set the script is stopped, and we can see that these 3 requests are executed 2 times, and I can set it to, for example, to 10 times, and it is executed once, second time, 3, 4, 5, 6, 7, 8, 9, 10 times. So these 3 requests are executed 10 times. So best practices for using loop controller, for example, organize your test plan, use loop controllers to group related actions and make your test plan easier to read and manage. Avoid infinite loops. Be cautious when using the forever option. Make sure you have a proper stopping condition, like set a test duration in the thread group to avoid tests running indefinitely, continuously. And you can combine with other logic controllers, or combine the loop controller with other controllers like if, while controller to create complex user behavior patterns. And monitor resource usage. Large loop counts or forever loops can consume significant resources, so monitor your machine's CPU, memory, and network usage during testing. So in a summary, loop controller is a powerful and flexible tool in JMeter that allows you to repeat actions, simulate realistic user behavior, and create sophisticated test scenarios. By controlling the number of iterations and combining it with other logic controllers, you can design a detailed and dynamic test plans tailored to your specific needs. So let's talk a little bit about if controller. So if controller in JMeter is a logic controller that enables you to execute its child elements, samplers, controllers, or other test elements only if a specified condition evaluates to true. It is a powerful feature that adds conditional logic to your test plan, allowing you to simulate real-world user behavior where actions depend on certain conditions. How the if controller works. If controller evaluates a given condition before executing its child elements. If a condition evaluates to true, the if controller executes its child elements. If it evaluates to false, the controller skips over the child elements. So key features of and configuration options are, for example, the condition. So the condition itself, this is the main configuration option for the if controller is the condition field where you specified the condition that needs to be evaluated. The condition can be a simple or complex JavaScript expression, a JMeter function or variable. The expression should return either true or false. The option interpret condition as a variable expression. When this option is enabled, checked, JMeter treats the condition as a variable expression and evaluates it using JavaScript or JMeter expressions. If unchecked, JMeter interprets the condition as a static string, which is less common but might be useful in certain scenarios. So they evaluate for all iterations if enabled. If this option is enabled, the if controller re-evaluates the condition for every iteration if it's parent, thread group, or a loop controller. This ensures that the child elements are only executed when the condition remains true. So how to add how to use the if controller. So you need to add the if controller to your test plan. You need to configure the if controller, and you need to add child elements. Adding to test plan, you just need to right click and just choose, for example, for step 2, we just use the if controller, this one. So then we need to configure the if controller, we need to set some expression in the condition, and then we need to add some child elements. We have some examples of using if controller. For example, the first example is simple condition using JavaScript expression. For example, imagine a scenario where you want to execute HTTP request only if a certain variable, for example, login status, is set to success, and you need to use following expression. For example, this one. So vars.get login status equals success. Login status is in this example, the vars get login status fetches the value of JMeter variable login status. If it equals to success, the condition is true, and if controller executes all its child elements. In this example, we can have such a variable, a login status, but this variable may come from a bin shell post-processor for a previous request, or a regular expression extractor for the previous request, and so on. Or it can be the situation where you have user-defined variables at test plan level, and you just need to specify the correct variable name and its value. For example, let's use login status as success, and let's just run this test. Let's check once again. So clearing results, and check. Let's check this expression, for example, this one. And this is the first example of the first scenario, and the second example is to use complex condition using JMeter functions. Suppose you want to execute a request only if a random number is greater than 0.5, and you can have such you can have some function like JavaScript like a random number, and we can just try to execute this script. So this time it was executed. In order to see this the value of this number, so it is this time it is executed. Let's execute once again. So and the first scenario, you can have multiple conditions. You can use multiple conditions combined with logical operators like and or for instance, if you want to execute a request only if both conditions are met, we have following condition. So this one. This condition checks if var1 equals value 1 and var2 is greater than 10. If both are true, the if controller executes its child elements. And use cases for the if controller. So the if controller is highly versatile and can be used in various scenarios like conditional navigation, simulate user behavior that depends on specific conditions, such as navigating to different page if the user is logged in, or performing different actions based on user roles, for example, admin, regular user, error handling and recovery, handle errors by executing specific actions when a certain error code or response is returned from a server. For example, you can retry a request if a response code is not 200. Dynamic test flows. So let's add it. Dynamic test flows. We can create more dynamic and realistic test flows where the execution of certain actions depends on data extracted from previous requests or random conditions. And performance and load testing. Simulate different user paths and interactions based on certain probabilities or thresholds to better reflect real-world scenarios. And best practices for using if controller. Keep conditions simple. While the if controller supports complex conditions, its general it's generally a good practice to keep them simple and easy to understand. The complex expressions can make test plans harder to maintain and debug. Use JMeter functions wisely. Leverage JMeter's built-in functions like JavaScript or Jxl free for evaluating conditions. But these functions are optimized for performance and provide more flexibility and pure JavaScript. Avoid the heavy JavaScript operations. JavaScript-based conditions may impact performance, especially if evaluated frequently or involve complex logic. Optimize your conditions, so consider using more efficient expressions. Test your conditions. Before running a full-scale test, verify that your conditions are working correctly. You can use JMeter's debug sampler or view results tree listener to inspect variable values and ensure the correct branches of the if controller are executed. Use other controllers. Combine the if controller with other logic controllers like loop controller, while controller, and so on to create more dynamic and sophisticated test scenarios. So in summary, the if controller allows you to add conditional logic to your test plan, executing child elements only when a specified condition is met. You can use JavaScript, JMeter functions or expressions to define the condition. Also, it is particularly useful for simulating dynamic user behavior, handling errors, and creating realistic test scenarios. Combining it with other logic controllers can help create complex test flows. So it can happen that the expression that you set in the if controller is not working. For example, this expression like vars.get login status equals to success. For example, let's set. So for example, this expression like vars.get login status equals to success is not working, and you need just change the expression to be like this one. So you need to change it like JavaScript login status equals to success. For example, in first case, for example, let's use first case, and I will demonstrate that it is not working. So I'm using vars.get login status. This is variable name, and this variable name comes from user-defined variables. And let's execute the test. And you can see that the requests 1, 2, and 3 are not executed, but the debug sampler says that login status is equal to the correct variable success. And in this case, when I change the expression to be in a JavaScript format like JavaScript, and then this expression is treated as JavaScript, and login status, the variable name equals to success. And let's execute the test once again. And you can see that all the requests are executed successfully, and the debug sampler also says that the login status is equal to success, and the corresponding expression is working fine. So let's talk about JMeter reports. We have two types of reports. We have real-time reporting like listeners, and we have JMeter dashboard report, which is an HTML report. When speaking about real-time reporting about listeners, we have following types. We have view results tree, we have view results tree in table, aggregate report, graph results, and summary report. Some of these reports you already know, and we will talk about HTML report. The key features of HTML report are response time percentiles, error statistics, throughput and latency graphs, response time over time, and request and response metrics. So I have prepared following project for testing the report generation. So we have 4 steps. Step 1, login, open product list, open product details, and logout. And these requests are pointing to blazedemo.com, and I have used some timers. For example, the think time for opening product list is 2 seconds. The think time of opening product details is 3 seconds, and the user should read the product details about 4 seconds, and after this the occurs logout step. And I have added the view results tree in order to check this test script if everything runs smoothly. I will run it with one single user. So let's run it. Everything is fine. So I'm clearing results, and I will set number of threads to be, for example, in order just to test the report generation, I will use one thread, and will loop count will be 20, for example. I'm saving the report. After this, I need to open in order to generate the output file. I will need to use some commands. So the commands are as follow. So if you see, I have prepared following commands. The first command is for running JMeter test script and generating a log file with all the requests and all the information related to errors. And for this, I'm just using JMeter -n -t test plan and -l and test result GTL. And after this, we need to generate the report. And the command for generating the report is JMeter -g. I'm giving as input the log file, and based on this log file, the output, the report is generated in the output folder. So let's run the test plan first. So I will need to just right click on JMeter bin folder and okay, let's open the command line. I'm typing F cd. So now I am in the bin folder, and in the bin folder I need to, okay, the test plan is saved, and I will need to go to the test plan folder, test plans. So I will need to use the command. Okay, so the command is prepared. So JMeter, I'm giving the test plan, then I'm giving the log file. So let's test this. Okay. Okay, so everything is fine. So let's just run it. Okay, so the test was run, and now we need just to check the output file. So we have in test plans in logs, and here we have a output file, the log file, which is named report generation test result.gtl. Okay, and we will use this file in order to generate the report. So let's prepare the the command. So I need to point to the right folder. So this one. Okay, and after providing the log file, I need to provide the output folder for the report to be generated. So I will just let's so I will provide this folder. After preparing the command in Notepad, you can just copy it and okay. So let's check once again. So everything is fine. So and press enter, and we will have a report generated. Okay, the report is generated. Let's check the output folder. This is the report. So the folder, and this is the HTML report. And let's it has two folders and two files. So content, like CSS, JavaScript, and pages. And let's open it and let's check it. Okay, I have opened this file, and this is how it looks. So we have source file name, we have start time, we have end time, and this is the basic information. So we have a summary as well with the passed and failed requests. So everything, all the requests were passed. So this summary is green, and we have different charts like overtime, throughput, and response times. Let's check response times. Okay, these are the response times per request, per each request. So we have this chart, and we have response time overview. We have here where requests having response time less than 500 milliseconds, when requests having response time more than 1.5 seconds, and when more than 500 milliseconds and less than 1.5 seconds, and the request in error. Time vs threads chart. We have also response time distribution. Let's check the overtime, response times over time. So we have active threads over time. So only one thread. Response time percentiles over time. Successful responses. Okay. Bytes throughput over time. Then latencies. Then we have connect time over time. Okay, and also we have throughput. transactions per second, and so on. Okay, this is one report, and let's check what will be the result if we will run, for example, 50 users, 50 concurrent users. First of all, we need to change here to be 50 concurrent users, and ramp up period in seconds will be 1 minute. Let's save it, and let's use following command. The second log file. Okay. So as you can see, we have some intermediate results, and in the first intermediate result, we have active 7 threads. Average time is 1 second. Okay, we have 32 threads. And now all 50 threads are loaded into the system, so they are working now in parallel. So we have 50 concurrent users working at the moment. Okay, the test is run successfully, and let's check the file. Let's check the log file. So the second log file is much more greater than the first one because it contains much more results. So if you want, you just need to open. For example, let's open this one, and as you see, it contains the information related to all of the requests, their status, their time, average response time, and so on, and the name of request. Okay, let's use this log file in order to generate the report. Let's prepare the command. So, okay, just running the command. It should create the folder. It created the folder, and this is the report. And you can just open it. So let's see. Let's see, for example, the active threads over time. As you can see, there are not one thread, but there are 50 concurrent threads which have worked in parallel. And also you can see the statistics on the dashboard of this report. We have for each request we have statistics and the number of samples. So we have average time for each request. We have minimum and maximum time, and also we have error percents. So as you can see, the error percent is 0 for all the requests. So everything was fine. And I just wanted to mention that instead of using a simple thread group, you could probably use some other type of thread group which will ramp up all the threads and then will constantly keep these threads working in parallel, for example, constantly, for example, for 2 hours. And after 2 hours, it can just decrease the number of threads slowly in order to not stress the system. Also, when ramping up, you need as much, for example, if you have 1,000 users, then you need to increase the ramp up period of time in order to not to stress the system. So let's talk a little bit about once-only controller. In JMeter, the once-only controller is a useful component within a thread group that ensures a set of samplers, requests, or actions, HTTP requests, JDBC queries, and so on, are executed only once per thread, regardless of how many times the rest of the test plan is repeated. So we have key features of the once-only controller. Execution only once per thread. When placed inside the thread group, any samplers or logic controllers inside the once only controller will execute just once during the entire test run for each user or thread. The rest of test elements outside of the controller will follow a normal behavior, which could be repeated multiple times based on the loop or test plan configuration. First iteration, the samplers under the once-only controller are executed during the first iteration of the thread group. In subsequent iterations, they are skipped. Thread group scoping, since it only works within the scope of a thread group, each user or thread will execute the contents of the once-only controller once. If multiple threads are running, each one will still execute the logic within the once-only controller once, but independently. Common use cases. Login authentication scenario. If your test requires each virtual user to log in before performing actions, but you only want to log in once per user session, the once-only controller is helpful. You would place the login requests inside the once-only controller, ensuring that each thread logs in once and then continues with subsequent actions. Setup actions. Any initial setup, such as establishing database connections or loading data, which only needs to happen once before subsequent requests, can be placed within this controller. And we have such use case like session initiation. In cases where you need to initiate a session, like generating session tokens or cookies, the once-only controller ensures this step is done once before the main flow of requests. And how to use once-only controller, we need to add a thread group. In your test plan, add a thread group to represent your virtual users. Add once-only controller, right-click on the thread group, add logic controller, and then once-only controller. Add samplers, add your samplers, HTTP request or JDBC request or any other requests inside the once-only controller by right-clicking on it and selecting the appropriate samplers or logic controllers. And run the test. When you execute the test, the samplers inside the once-only controller will run once for each thread, even if the rest of the test plan repeats. And this is an example of test script which will include once-only controller. In order to add the once-only controller, just click on the thread group, add logic controller and once-only controller. And as you can see, it is a pretty simple controller. It has only name, and if you want to open documentation on this element on this controller, you just right-click on it and selecting help, and you will be presented with so you will be presented with the documentation on Apache JMeter.org website. There is a documentation for each element, and in this case, this is once-only controller. You can read the description, parameters, and examples. Okay, so I have added once-only controller in my test script, and now I can just place it, for example, place it here. And I will disable for a moment, and I will show you how the test script runs. I will run it for 2 loops, one single thread and 2 loops. Okay, let's run it. And as you can see, we have login request, then we have 3 requests, and we have again the login request is repeated and we have 3 more requests. And in case if we want to execute login request only once for each thread, we can just add this controller. We will enable it, and we will place the first step like login step inside the, just drag and drop it to once only controller. And let's clear results, and let's run the test once again. And in this case, the login request will execute only once per thread. So this request is executed only once. And we have 3 requests. And since we have 2 loops, these 3 requests will be repeated twice. So this is once and twice. And as you can notice, the login request is executed only once. And for example, if we execute the thread for five loops, and as you can see, the login request is executed only once, and we have the subsequent 3 requests: once, twice, 3 times, 4 times, and 5 times. These are repeated 5 times. And if we add, for example, 2 threads, you will see that the login request is repeated 2 times. Each request is for a separate thread. So we have 2 threads, one ramp up period 1 second, and loop count is 5. And let's execute it. You can see that login request is executed first, and it executed 1 login request for each thread. So we have 2 threads, we have 2 requests, 2 login requests. The test is executed, and as you can see, we have only 2 login requests, each login request for each thread, and we have these 3 subsequent requests executed multiple times. As you can notice, we have no login requests in the list. We have only 2 login requests. Let's talk a little bit about simple controller. So we have key points, use cases, and benefits. Simple controller is a lightweight organizational tool used to manage and organize test elements in your test plan. It doesn't directly impact how the test is executed, but helps in structuring the test plan and improving its readability and maintainability. So we have key points. Organizational purpose, the simple controller doesn't perform any specific actions on the requests or modify them. It simply holds and groups various elements like samplers, logic controllers, timers, and so on, allowing you to structure your test plan more clearly. Improving readability as your JMeter test plans grow in complexity, using a simple controller helps break down the plan into logical sections. This makes it easier to manage large test plans by visually separating different parts of the plan for specific purposes or functionalities. And the hierarchy and the execution flow. JMeter executes test elements in a hierarchical order. Using simple controllers, you can place related test elements under a single node. This doesn't affect the execution logic, but makes it easier to identify related groups of elements in the plan. No special execution control. The simple controller does not apply any conditions or criteria for executing the requests under it. It is not like other JMeter controllers such as loop controller or if controller that control the flow of execution. The elements under a simple controller are executed in the order they appear, just as if they were at the same level in the test plan hierarchy. And we have use cases. We have grouping related requests. You might group a series of HTTP requests under a simple controller to represent a particular functionality of your application, such as login flow or product checkout flow. Modularizing the test plan, you can use simple controllers to modularize sections of your test plan so they can be enabled or disabled easily without affecting the overall structure of the test plan, of the test. And enhancing reusability. If you want to reuse certain requests in different parts of your test plan, you can place them under a simple controller. This allows you to easily reference and copy the controller along with all the elements it contains across multiple sections. So let's we have here a simple script which have 4 steps, and these 4 steps are included by using simple controller. And for example, first step includes 1 request, and second step will include 3 requests, and so on. And for example, when you have 1 request, it is okay. It is okay to have a simple controller, but it is more useful when you have, for example, 3 or more requests, and you can group these requests by using simple controller. Some of you will, of course, will say that we have a transaction controller, for example. So we have a transaction controller, and we can use transaction controller, but the transaction controller adds some overhead to complexity of your test script. Transaction controller should first of all should generates sample, and it also calculates the sum of response times of all the child elements. In simple controller, you have no logic, so you have no overhead to your to the complexity of your test script. So you can use it to modularize your test script, to make your test script more readable. And for example, I will create another thread group with some requests. So I have created another thread group with some requests which are not grouped together and which are not modularized. So of course, this thread group is much more complex to read than the first thread group. The first thread group is much more readable. So you can read your test script by like you read the chapter. So you can name each step, and each step can have one request, or can have 3 or more requests, as many as you want. And you can have in simple controller not only the requests, but you can have, for example, some other controllers, for example, if controller, or while controller, loop controller, and so on. You can have, for example, timers like you have at the request level, but you can have it at a simple controller level, the timers, and you can have as well assertions. So you can have a response assertion at the request levels, and you can have these assertions at the simple controllers level. And we will talk about the benefits. So first of all, it is better test structure and readability, and easier management of complex test plans, and of course, like I've mentioned, no performance overhead, since it doesn't influence the actual execution of tests. Let's talk a little bit about while controller. So we will analyze where it is used, setting up a while controller, examples of conditions, how the while controller works, practical use cases, and the tips and best practices. So the while controller is a useful logic controller that allows you to control the execution of a set of test actions based on a specified condition. It repeatedly runs its child samplers and controllers as long as the condition evaluates to true. So we have like functionality. The while controller is used to create loops in your test plan. The loop continues to execute until the provided condition evaluates to false. Once the condition becomes false, the controller stops executing its child elements and exits the loop. Where it is used? So the while controller is often used in dynamic looping when number of iterations is not predefined, but instead depends on a certain condition, like the response from the server or variables being updated during the test run. And conditional execution to repeat a set of samplers or actions as long as a certain condition holds true. Setting up a while controller. So here's how you configure a while controller. Condition. You specify the condition in the while controller, and this condition is evaluated at the beginning of each iteration. The condition can be a variable, a JMeter function, or any other condition that resolves to either true or false. Common ways to set the condition. Use of variables. You can check the value of a variable, for example, var, where var is a JMeter variable that can change its value during the test run. Empty condition. If you leave the condition empty, it creates an infinite loop until it is manually stopped or the test completes. And the expressions or functions, you can use JMeter functions like JavaScript to evaluate complex conditions. For example, JavaScript counter is less than 5. Examples of conditions. We have a simple variable based condition, for example, like this one, like my variable. The loop will continue as long as my variable is evaluated as non-empty and non-zero. We have Boolean expressions like this one. The loop JavaScript counter is less than 10. The loop will execute until the value of counter variable reaches 10, and check for the end response. You could also base the condition on a response from the server, such as stopping when a specific response is received. For example, when a login fails. So how the while controller works. At the start of each loop iteration, the while controller evaluates the condition. Then, if a condition is true, the while controller executes its child elements, like samplers, other logic controllers, and so on. Then, after executing all child elements, the condition is checked again. If the condition is false, the controller exits and the flow continues to the next element in the test plan. Practical use cases. We have login attempts. You might want to try logging in multiple times until successful. For example, you can repeat the login sampler until a specific response like login success is returned. Polling until condition met. For example, polling an API until a particular status is returned. For example, waiting for a job to complete or a transaction to finalize. And custom looping. If you need more complexity than what the standard JMeter loop controller provides, you can use the while controller to loop based on dynamic conditions. Tips and best practices. Avoid the infinite loops. Be cautious with the while controller condition. If you mistakenly create an infinite loop by leaving, for example, by leaving the condition empty or having a condition that never becomes false, it can cause JMeter to hang or consume excessive resources. Debugging. While working with complex conditions, use debug samplers or view results tree listeners to monitor the condition values and execution flow to avoid issues. Nested controllers. You can use while controller inside other controllers or loop structures for more complex test logic. And I will show you this is a sample test script by using while controller. So we have 4 steps. Step 1, step 2, open product list, step 3, open product details and logout. The step 2 is placed inside the while controller. And in the while controller we have following expression like JavaScript, which evaluates that specific variable, my counter, is less than 5. This variable could be initialized in 2 ways. For example, you can have a user-defined variable like myCounter, which is initialized to 1, or you can have a bin shell post processor, which initializes the counter to 0. And inside this condition is evaluated at the start, and then we need to, inside the while controller, we need to increment this variable myCounter in order to avoid the infinite loop. So we need to increment it, for example, in a bin shell post processor. We are just retrieving the value of myCounter, then we increment it, and then we set this value to the same variable name, like myCounter. And we log, for example, this information for example, for debugging. And for example, if we initialize this counter to 1, so it should iterate 4 times. So from 1 to 5, less than 5 is 4 times. And let's execute this script. So we have login request, which is executed first, and then we have the product list request, which is executed inside the while controller, and it is executed 4 times. 1, 2, 3, 4 times. Then the loop exits, and it continues with the next request or the next element in the test plan. So let's it is executed 4 times, and let's comment. Let's disable user-defined variable, and let's enable the post processor, which is inside the login request. This is previous request previous in respect of while controller, and here we initialize my counter not to 1 but with 0. So in this case, from 0 to 5, and the condition is less than 5, we should iterate for 5 times. And for example, let's execute this script. We have login request and we have product list request, which is inside the while controller, and it should execute 5 times. It is executed 5 times, and then the script continues with the next request. So in conclusion, I could say that the while controller provides a flexible looping based on dynamic conditions, making it valuable for complex load testing scenarios. Proper use of while controller can help you simulate real-world scenarios like retries, polling, or conditional test flows. Let's talk a little bit about for each controller. For each controller in JMeter is a powerful tool used to iterate over a set of elements, such as variables or parameters within the task plan. It allows you to loop through items dynamically, making it particularly useful when you need to perform repeated actions on different data sets, such as iterating through items in a list or executing the same request multiple times with varying input values. Key features: iteration of variables, dynamic execution, nested controllers, and index-based looping. Iteration over variables. For each controller iterates over a set of variables that follow a specific naming convention. It works by looping through each variable, matching the defined pattern. Dynamic execution. It allows you to dynamically run other JMeter elements, for example, HTTP requests, samplers, within the for each loop, enabling complex test scenarios within varying input data. Nested controllers. The for each controller can be nested within other controllers, such as if controllers or while controllers, to create even more complex test flows. Index-based looping. You can control how the loop iterates through the elements by defining start and end indices, allowing precise control over the iteration process. How to configure? So we need to add for each controller to the test plan, configure the for each controller, add samplers or controllers within the for each controller, and using the output variable. Add for each controller to your test plan. Just right click on the thread group or wherever you want the controller to be placed, add, then logic controller, and choose for each controller option. Configure the for each controller. So we need to have input in order to configure for each controller, we need to input variable prefix, output variable name, and start index and end index. Input variable prefix. This is the prefix of the variables you want to iterate over. For example, if your variables are named item 1, item 2, you would enter item and underscore as the prefix. Output variable. The name of the variable that will hold the current iteration's value. For instance, if you set this to current item, you can refer to the current value in the loop as current item, for example. Start index and ending index. These fields define the range of variables the for each controller should iterate over. By default, it starts from 1 and ends when no more variables match the pattern. So we need to add samplers or controllers within the for each controller. So we need to just place the HTTP samplers, JDBC requests, or any other controllers inside the for each controller. These elements will be executed once per each iteration of the for each loop. And using the output variable, during each iteration, the specified output variable will hold the current value. You can use this variable in your requests to dynamically change the input data. Best practices. We need to use proper naming conventions. Ensure the variable names follow consistent naming pattern to be correctly recognized by the for each controller. Test in isolation. Test the for each controller with simple variables first to confirm it iterates as expected before integrating it into more complex test scenarios. And handle dynamic data gracefully. Make sure to account for scenarios where the expected data set might not be present, and plan for such cases with appropriate error handling. So in the conclusion, the for each controller is versatile and allows you to build dynamic, data-driven testing flows, enhancing the flexibility and efficiency of your JMeter test plans. As example scenario, for example, suppose you have variables item 1, item 2, and item 3 set up in JMeter, and you want to perform an HTTP request using each of these values. Input variable prefix should be item and underscore, and output variable name should be current item. The for each controller will loop through item 1, item 2, and item 3, setting the current item to each variable's value sequentially during each loop iteration inside the for each controller. You can place an HTTP request that uses current item in its parameters, allowing the request to be dynamically adjusted for each loop iteration. So let's talk a little bit about switch controller. The switch controller in Apache JMeter is a logic controller used to control which child sampler or controller will be executed during a test run. It allows you to dynamically decide which one of these child elements to execute based on a specified index or variable value. This makes it useful for scenarios where you need to execute different actions based on specific conditions. So we have a switch controller. We have key features, configuration options, how it works, important notes, and practical tips. Related to key features, we have following topics like select one child element, dynamic control, and index-based execution. Select one child element. The switch controller executes only one of its child elements per iteration. Dynamic control. The selection can be used on a hard-coded index, a JMeter variable, or a JMeter function. And index-based execution. The child elements are E0 indexed, meaning the first child is at index 0, the second is at 1, and so on. Configuration options. Switch value is optional, specifies the switch value or specifies the index starting from 0, or variable function that determines which child element will be executed. If left blank, the first child element index 0 will be executed by default. How it works. The switch controller evaluates the value in the switch value field. Based on the evaluated value, it selects the corresponding child element. Index starts at 0, and only the selected child element is executed during the current iteration. If the switch value is out of range, higher than the number of child elements, or negative, no child element is executed. So we have important notes. Like zero-based indexing, always remember that child elements are indexed starting from 0. Out of range values, if a switch value evaluates to an invalid index, negative or higher than the number of child elements, no child is executed. And default behavior, if no switch value is provided, the first child index 0 is executed by default. And debugging. You can use the debug sampler to expect variable values and to ensure the correct child is being executed. And practical tips like integration with variables and functions. Combine the switch controller with JMeter functions like random or JavaScript for dynamic behavior, testing behavior. Use the view results tree listener to verify which sampler is being executed. And error handling, add assertions to ensure valid responses from the executed sampler. So this is practical example for switch controller. For example, we could have in friend group, we just inserting a switch controller. It is located under add logic controllers and switch controller. When inserting a switch controller, we can specify the switch value, which could be a variable or a function. For example, in this case, it is random from 0 to 2. So we can have inside the switch controller, we can have the corresponding HTTP requests, or we could have even other controllers, for example, simple controllers. For example, we could have 3 simple controllers. 1, 2, 3. Instead of this HTTP requests. So we are specifying the corresponding value. So in the use cases, for example, the first use case, the switch controller can be used to execute specific samplers based on variables value. For example, if a user type is admin, execute admin specific request. If user type is guest, execute guest specific requests. Randomized testing, you can combine the switch controller with a random function like random from 0 to 2 to random select one of the child elements. And protocol specific requests. For testing multiple protocols, for example HTTP, FTP, you can place samplers for different protocols under the switch controller and dynamically select the desired one. Example scenario 1, for example, we can have a hard-coded switch value. For example, we can have 3 HTTP requests, and HTTP request 1, HTTP request 2, and HTTP request 3, and switch controller configuration switch value 1. In this case, during each iteration, only HTTP request 2 will be executed. For example, if we have here we can have a function, but we can have a hard-coded value, for example 1, and we could have 3 HTTP requests, and if you can have one switch controller is 0 indexed, 0 based index, so starting from 0, this is 0, 1, and 2. So for example, HTTP request 0, HTTP request 1, and HTTP request 2. So in this case, if you can specify the value, switch value hard-coded to be 1, it will execute HTTP request 1 every iteration. For example, we can have example 2. We can have using variables. You extract a user role from a login response. For example, user role, which could be admin, editor, or viewer. Based on the role you want to execute specific request, define a variable role index that maps roles to indices. So admin is 0, editor is 1, and viewer is 2. Use the switch controller switch value set to role index. Place child controllers or samplers under the switch controller for each role. This setup dynamically executes the corresponding sampler based on the user's roles. And we can execute the specific random execution by using a random function. We can use the JMeter random function to select a child element at random. For example, switch value could be this one. This randomly selects one of the first 3 child elements. So let's talk a little bit about transaction controller. So we have such topics as key features, configuration options, when to use, result analysis, advanced tips, and limitations. Key features. So we have at the key features topic, we have such subtopics like group samplers into a single transaction, generate and aggregate result, nested controllers, option to exclude latency of child samplers. Such a key feature like grouping samplers into a single transaction, it means that it combines multiple samplers into one logic transaction, providing a consolidated response time for the entire group. Generate an aggregate result. It means that the transaction controller records the total elapsed time for all child samplers within the group. Nested controllers. It supports nested controllers and includes the execution time of all child samplers or controllers in the transaction. Option to exclude latency of child samples. You can configure it to exclude the response time of child samplers if needed. Configuration options. Generate parent sample. When checked, the transaction controller will generate a single result, parent sample representing the total response time of the transaction. When unchecked, each child sampler will also generate its individual result in addition to the parent sample. Include duration of timer and pre-post processors in generated sample. If this checkbox will be checked, the transaction time will include any timers, preprocessors, or post-processor applied within the scope of the transaction controller. If unchecked, these additional processing times are excluded. When to use? We have performance testing of, for example, we can use the transaction controller for performance testing of business transactions. Use it to measure the time taken for a business critical transaction, such as logging in, searching for a product, adding it to the cart, and checking out. End-to-end scenario timing, combine multiple steps in a user journey to see the total time taken for an end-to-end flow. Comparative analysis, measure the performance impact of changes to a system by comparing transaction response times before and after the changes. Also, we have a result analysis, we've generate parent sample enabled the results. In this case, the results tree will show a single entry for login transaction with a total response time of all child samples combined. Individual samplers will not appear unless you view them in the request logs. Without generate parent sample enabled, the results tree will show individual entries for each sampler along with a separate entry for the parent transaction. Advanced tips. Nested transaction controllers. You can nest transaction controllers within each other to measure sub-transactions as a part of a larger transaction, excluding timers. Be cautious when using timers inside the transaction controller. If you want accurate transaction timings, ensure to configure the option to include or exclude timers based on your requirements. Customizing reports. Use listeners like the aggregate report or summary report to view and analyze transaction times. Integration with assertions. Add assertions to the transaction controllers or each child samplers to ensure performance thresholds are met. Limitations. Accuracy of metrics. If timers or other elements are included, the transaction time might not solely represent the response time of the requests. Complexity. Using multiple nested controllers may complicate test plans to ensure they align with your test objectives. So let's analyze the transaction controller practical example. So I have added a thread group, I have added a transaction controller. Let's untick these two checkboxes. Let's comment the timers. Also, I have added in the transaction controller, I have added two requests to blazedemo.com, and let's run this transaction controller as it is with checkbox unchecked, and let's see what is the result. So the first request took 1 second, the second request took 4 seconds, and the transaction controller took 5 seconds. So this is the sum of these two requests. And if we tick generate parent sample, let's check what is occurring. So only the transaction controller is a parent sample is generated, and these two samples are not appearing in the list. These two samples are included inside the transaction controller sample. So let's add, for example, another listener, for example, aggregate report, and let's see what is the result with this checkbox unchecked. Yes, the HTTP request is appearing, the transaction controller is appearing in the corresponding list. This transaction controller could be renamed, for example, it could be renamed in a meaningful way, so the reports will be meaningful. And let's check the generate parent sample. Let's see what is the result in the aggregate report listener. So only transaction controller is appearing. Okay, let's check include duration of timers and pre and post processing the generated samples. And for this time, I will enable the constant timers for 3 seconds each. And let's see what will be the result. So the transaction controller includes and the corresponding timers. And if we uncheck this checkbox, let's see what will be the result. And the transaction controller does not include the timers, so this is 1 second only.